table is a central tendency. Okay, it's a central tendency. Now, what is central tendency? When you say central tendency, what is it? Okay, so let me go to my next slide. So my question is, what is central tendency? Okay, when you talk of central tendency, what is it? Yeah, somebody should help me. When you say central tendency, what are you referring to? Yes. When we talk of central tendency, please, what are you referring to? Central tendency. What is it? What is it at all? Okay, that central tendency. Yes.
Hello, sir.
Yes, please.
Central tendency is a single value that
Okay.
represents the center of entire data.
That represents
The
the
center
center of
of
entire data.
a data
Okay.
set.
Okay, that's good. That's very good one. Okay. Anything more? Anything more? Anything more? Yes. I think that is basically what our brother has said. Okay, so we talk of when you talk of central tendency, it's just a single value representing the what? The pivotal
Data set.
of the data set. Okay, so uh, a single value, a single value, okay, that represent the what? The pivot, the pivot, or maybe the center, okay, of the data set, okay, of the data set. That's what our brother said, and that's absolutely correct. Okay, all right, good. So when we talk of what central tendency, just a single value, more or less a single value. That is what that is summarizing the what the result. Okay, it's a single value that is giving is more or less a single value, a single value. Okay, okay, value that is summarizing. Okay, our what result basically. Okay, or our data set. Okay, so it's very, very, very important. Okay, why is central tendency very important, if I may ask? Why is central tendency very important? Why is central tendency very important? Yes.
Okay. It helps us to summarize
Okay.
bigger data.
It's help us to summarize what bigger.
Summarize a bigger data.
Okay, good. That's very good. I hope you all agree to that. Hello, are you there? Okay, so one of the key thing about central tendency is that okay, so one that's helps to what it helps. Okay, but even before we get to that, what are the measures of central tendency? Okay, what are the measures of central tendency? So measures of central tendency before measures of central tendency. Okay. Okay, so when we talk of measures of central tendency, we are talking about the what?
The
The
mean, mode, median.
good. Okay. So let me okay, so let me take it the easiest way. This is a mode. Okay, median, and what? Mean. Okay. All right, good. Okay, mean also known as average. All right, good. Like that. So these are the what? These are the central what? These are the central uh measures of central tendency. And what is it doing? What it does is that one key thing is that, as our brother said, it helps to what? To summarize, okay? So it helps to summarize the what? The data set. It helps to summarize the data set, okay? What else again?
with a
Okay.
single.
Yes, please. It helps to summarize the data set. That's good. What else again? Yes, anything more?
It
Yeah.
makes it easier to understand and compare different data sets.
Okay, so which means that it's provide basis for comparison. Okay, so provides what? Provide basis. Okay, basis for comparison. Comparison. Okay, comparison of what? Comparison of data sets. Okay, that's very good one. Good one. Okay, so it provide what basis for comparison. Okay, so I can say that the mean age of what of the guys in the class is maybe 28. I can say the mean age of the ladies in the class maybe 25. Okay, so it actually provides basis for what basis for comparison. Excellent. Okay, so any other points? Any other points? Yes. Why? Yes, we're talking about significance of what? Those of you just join us. We're talking about significance of what? Of central tendency. Why is it important at all? Okay, so this is what we are looking at. Okay, and then
Um,
yes, please. I'm waiting. Yes. What else again?
it can be used to find to determine the direction of maybe a test score or direction of the direction that the data is moving towards.
Okay, when you say direction, what does it mean in this context? Moving direction, the data is moving to. What does it mean? Can you throw
Um,
more light on that?
let's say if you have a score and then you know the mean and then you know the median, you can be able to tell whether the individual is maybe average or above average or below average.
Okay. Well, you said something about directionality, which is very good, but your explanation you are providing is not there. But what we can see is that, like for instance, I don't know whether please are you familiar with the word normal distribution?
Yeah.
Yeah. Good. So let's take something like that. Let me show you something here. Let me draw. Okay. So let's see if a data is like this. If my data is like this, okay, like that. Now, if I have a data like this, and if I have the mean, the median, all in this, so let's say this is my data distribution, and if I have my mean and median all in this central location here, okay, we can say that the data is what is normally distributed. Please, you understand what I'm saying here? So when we have the word, so you see this one will give probability of all the values in the data set. And when I get the probability of all the values in the data set, and I do the plotting for all of them, then we get some sort of distribution. So this distribution that I'm talking about, if I have the diagram like this, okay, based on the central tendency, I can actually give information about the nature of the distribution. I can see that maybe the data, okay, is not following normal distribution. And in terms of direction, you can say that maybe it is skewed towards left or it is right skewed. Okay. All right. So you can even use the data, okay, use the data to talk about the skewness of the data. Okay, whether it is following the symmetrical distribution. Is it right skewed? Is it left skewed? That sort of thing. So the central tendency can also help us to actually determine the distribution of the data in terms of what the skewness. Okay, so also we can say that it provides information 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 on the word on the nature of the distribution of the data data distribution. Okay, so in terms of what? In terms okay, let me so that we don't hide it. Okay, good. So in terms of what? In terms of in terms of skewness, in terms of skewness. All right, good. So it provides the information on the what, on the nature of the data distribution in terms of skewness. Okay, so for instance, if I have data like what I've drawn here, so when you come to distribution, one of the things that we do is that we can actually determine this distribution show probability of each variate in the data. So when you use those probability to draw the data set, you get something like that. So when I have all my mean, the median, and then the mode all in one position like the way I've drawn here, then we can say that the data is what? The data is normally distributed. Okay, so like based on my drawing here, when the mean, the median, so here like that. So for instance, okay, for instance, okay, so when the mean is equal to the median, equal to the word, equal to the mode, okay, we can say that the data is what is normally distributed. Okay, normally distributed. Okay, distributed. Okay. All right, good. Okay, good. Are you there? Are you there? Yes, please.
Can one say it is evenly distributed too?
Yes, I mean, when you say normally distributed, we say that it's evenly distributed. That's basically, I mean, the layman's version of what you just said. Okay.
Okay.
All right. That's the layman's version. Okay. So when we have this, so another thing apart from the summary of the data set, and then providing basis for comparison of the data set, another information that provides is that it also helps us what, to describe the nature of the data distribution in terms of what. So once I get the data, and then the mean, the median, and the mode are approximately the same, then it means that the data is normally distributed. The population is what, that particular data is normally distributed in the population. Okay, all right, good. And another one important thing is that we've not maybe one thing that I could add to this is that so based on this one, okay, another thing we can say that sometimes we can say that like what I've given here. So I've given one instance here. Let me put this one up a little bit so that, okay, I've given one instance here whereby we are saying that the data is what, is normally distributed. So when you say data is normally distributed, we have the mean, the median, and the mode being what, equal. Okay, but we have instances whereby the mean, so when we have something we call positively skewed. Okay, when we say the data is what, is positively skewed. All right, so positively skewed, okay, it means that positively skewed, okay, skewed, okay. So when you say positively skewed, another term for it means that it is right skewed, okay. It means that it's what, it is right skewed, okay. So when we say the data is positively skewed, what can you use to determine that? We can also use the central tendency. The central tendency will be in this form, okay. Another term for right skew is that we can say that it is what, the tail, the tail points what, it points right. Okay, so okay, so that's another way to do it. So tail, the tail of the data, the tail points right. That is when we say positively skewed or right skewed. Okay, all right, good. So, okay, positive skew. No, sorry. So let me do it this way, straightforward. Okay, so it is right skew or positively skewed. Okay, it means that the tail, the long tail. So if let me draw something here like this. So here, based on what I just said in terms of the nature of the distribution, I just say that when the mean, the median, okay, and the what, and the mode, if they are all the same, we say this one is what? We can say that this is a normal what? Normal distribution. And I've just drawn it for you to see. And then we can also have a situation whereby we will have the what? We'll have the positive skew. Okay, the data is positive skew. The data is positive skew. Okay, so positively skewed data is also known as right skew. And this one, what it means is that the tail of the word of the data is to the what? Is to the right. Okay, the tail of the data is to the right. Okay, so when you say that the data is positive skew, it means that the tail. So if I could draw something like that here, okay, if I pick this and then say that I'm drawing something here like this. So let's say when you say positive skew data, it means the data is like this, like that. Okay, so you see that the long tail is towards the right. Okay, so that's it. Okay, this is positive skewed data. Okay, which means that the long tail is towards the what? Is towards the right. Okay, great. So something like that, when it comes to the positive skewed distribution, okay, what is going to happen is that there's a characteristic. In that case, such data, the mean is greater than the what? Than the median. Okay, than the median. And the median is greater than the what? Greater than the mode. Okay, so when we say that the data is what? Is a right skewed or positively, excuse me, is positively skewed, then the mean is greater than the median and the median is greater than the mode. Okay, all right, great. And then we can also get the opposite version of that. Okay, the opposite version, okay, of this, okay. Okay, so let me bring this one down here. Okay, so when I get the opposite version of that, which is the what? Which is the negatively skewed, okay? Negative. Okay, so negative, okay, negatively. Okay, so negative skew data. Now, when it comes to negative skew, what happens is that, okay, it's just opposite of what I have here. Okay, so who can tell me the opposite of what I have here? Who can tell me the opposite of what I have here? Okay, now look at what the first one that I wrote. So what is going to happen?
Go to the left.
Okay, great. So here, everything is going to tend this way, right? Okay, so this one, it means that the mode is the highest. So everything that I've then, yeah, you see that this one was the mean was the greatest and mode was the least. Always the median will be in the middle. Don't forget that at all. Median is always middle. It doesn't matter how median is middle. Okay, great. So in this case, when I draw it, it's going to look this way. So here, it will be the tail will go like that and it will go this way. Okay, like that. Okay, so it will go like that. So when we have the word, when we have the graph this way, this one it is what? It is negatively skewed data. Okay, negatively skewed data. All right, good. In this one like this, okay, this is, you can see that almost perfect symmetry. This is what the normal distribution, okay, normal distribution, very beautiful like that. This is normally distributed data. Okay, great. All right, that one, the mean, the median, and the mode, they are what? They are at the just exact, they're almost the same. Okay, like that. Okay, like this. So this is normal distributed data. Okay, great. So apart from the central tendency, okay, apart from the central tendency giving us information about the summary of the data, it provides basis for comparison, and also it helps us to know the nature of the word of the data distribution, because it's very, very important when you are going to do inferential statistics. The nature of the distribution will help to choose even the type of statistics that you're actually going to perform. Okay, so when we say it is what, when the, so normal, this, when we have the mean, the mode, and then the median being the same, we say that the data is what? The data is normally distributed. When it is positive skewed, which means that the tail is pointing towards the right, okay, that one, the mean is the highest, okay? We say that you can put this one in your head, okay, the mean is the highest, okay, and then so always the median will be in the middle. So once I say the mean is the highest, okay, and when is the negatively skewed, okay, it means that the mode is the highest and then the mean is the least. Always remember the median will always be in the middle, okay, is the middle of the data. Okay, good. So yeah, so central tendency will provide this information. Another thing that central tendency will do that if not talked
Hello,
about.
Doc.
Yes, please.
Hello, Doc.
Yes, please.
Please, go back. So the negative skewed.
Yes, please.
The right. Isn't it supposed to be left or?
The negatively skewed. The tail is towards the so where the tail is pointing. Oh, sorry, my writing here. Sorry, I copied this and left. Sorry, thank you. Yes. Sorry, thank you about it. Thank you. Okay, great. Now I copy what is there and pasted it here. All right, great. So the tail is pointing towards the left. Okay, so where? Okay, so the tail is to the what? Is to the, so here is to the right. Okay, and the tail here, the tail. Okay, let's say the tail is to the left. Okay. Okay, so tail is to the right. Okay, great. Okay, thank you. All right, so yeah, so here, all right, so that is the negative skew. Okay, good. So for negative skew data, for normal distribution, mean, median, and mode, okay, they are all equal. For mean, when mean is greater than the median and greater than the mode, okay, like in this order, we say that the graph is what? Positively skewed. The shortest way to put in your head is that positively skewed, mean is the highest. Negatively skewed, mode is the highest. Okay, so that you don't forget it. Okay, good. All right, so this is that for in terms of describing the nature of the data set. Okay, then another thing that is very important that you've not talked about is that to identify outliers. Okay, so remember that last week. Okay, so another significance of a word. Let me put it here. Another significance of a word of a central tendency. Central tendency. Okay, good. Okay, another significance of central tendency, okay, is also to do what? To identify outliers. Okay, outliers. Now, you remember that last week when we had a lecture, I made mention of children's party. And then I asked the person that they should give me the age of people who showed up in the party. So maybe you are performing party for kids. I mean, 2-year-old, 3-year-old, 4-year-old people. And then you ask them to calculate the mean for you. And they told you that the mean of people who came for the party is 28. What? 28 for party for children? Then clearly you can actually see that either grandmom and grandpa, okay, took their kids for the party, and then they were also counted as well. So based on the mean, you can actually tell the nature of the data set. Okay, and then you can identify the outliers. That now there's maybe one big value somewhere that is what taking the mean off what I'm expecting, because children's party, I expect that the age should be up to 10-year-old, because maybe the one who is even celebrating the birthday party is just a 3-year-old person. But they came and then they told me that the average age is like is 28. Then definitely it means that grandpa was there, grandmom was there, and then they recorded their ages as well. Okay, so another application of central tendency, or another significance of central tendency, is that it helps us to identify outliers. Okay, so that if there are extreme values in the data set, we'll be able to what detect them. Okay, all right. Okay, so it will show that now this particular value is fine, especially when it comes to mean and what and median. Okay, mean and what and median. So we can use the central tendency to identify outliers. So quick recap. So one, we can use central tendency to summarize the data set, okay? Because from the definition that our brother gave, that a single value that represents the pivot or the center of the data set, okay, or that summarizes the data set. So basically, central tendency gives a summary of the data set, okay? It provides basis for comparison, okay, and also it's what? It's also provide information on the nature of the data distribution. Is it skewed? Is it normally distributed? If it's normally distributed, what are we expecting? If it's normally distributed, we expect the mean and the median and the mode to be the same. If it's positively skewed, the mean is the highest. Positively skewed means that the tail is pointing right. Negatively skewed means that the tail is pointing left. In that case, the mode is the highest, okay, when it is negatively skewed. And then we just say that it can also be used to identify outliers in the data set. So outliers are the extreme values, okay, like a 90-year-old person in our birthday party ages that we collected clearly is an outlier. Okay, so having calculating the central tendency will help us to determine that or identify the outliers in our data set, particularly when it comes to the mean and then the median. Okay, all right, they'll give us information. Yes, please.
I have another one. I don't know if it is correct. Like,
Okay.
it will help us to know whether any of the central tendencies can be used for further statistical analysis.
Yes, of course. Of course. For instance, you see this distribution thing that we talked about. Yes, it actually provides some sort of basis for further analysis. For instance, I think you said that's a nice point. Okay, yes, it's a nice point as well. So this one is my fourth point. Okay, so 50 points here. Okay, so provide basis for further analysis. Okay, analysis. Okay, maybe especially when we are dealing with what inferential statistics. Okay, statistics. Okay, all right, great. Yeah, so it provides basis for what? For further analysis. So for instance, like comparing the means. If I want to compare the means, okay, so mean ages. So let's say if I want to compare, okay, the mean, okay, I can the mean ages of what? Of men and what versus what women. Okay, women in switch class. Okay, switch class. Okay, all right. So from here, the inferential statistics that I'm going to use is going to be where? This one, okay. It's going to be something we call t-test. Okay, so t-test. Okay, t-test like that. Okay, so here you can see that I'm going to compare the mean ages of what of women, mean ages of women women versus men. Okay. Oh, what is happening?
Doc,
Yes, please.
this one,
Compare the mean ages of. Okay. I think the way I picked it, the mean ages of. Okay, let me see. Men versus women. Okay, please go ahead. So I'm going to use something like t-test, but you can see that the t-test is further analysis that I'm going to perform, but I'm going to perform using mean. Okay, have you seen it? I'm going to perform using mean. All right, okay. Sometimes there are other ones that I could also do as well. I can do Mann-Whitney, I can do chi-square test, all those ones. Okay, we will talk about them briefly. Okay, good. But you can see that the further analysis that I'm doing here, I'm basing the further analysis. Okay, I'm basing the further analysis. Okay, on what? I'm basing the further analysis on the mean. So I'm comparing the mean ages of what men and women in the switch class. Okay, all right, and I'll use t-test. So yeah, so it provides basis for further analysis. Okay, especially when it comes to inferential statistics. Okay, please go ahead and ask your question, please.
This one there, I beg you. Our slide.
Yes.
It has not been released yet. I don't know
but you can say that after class because
okay.
Lecture is going on, so you can say that after class. Okay, good.
Thank you, sir.
I'll send them to you. Don't worry.
Okay,
all right.
Thank you.
So so we have the word. So quick recap of what we just talked about. So we have the words. We have 1, it provides summary of the data set. 2, provide basis for comparison of the data set. It provides information on the nature of the distribution of the data, whether it is skewed, okay, and we say that if it is normally distributed, okay, it means that the mean, the median, and the mode are equal. Okay, then it's normally distributed. If it is right skewed, which means the positive skewed, which means that the tail is pointing right. If it's pointing right, what it means here is that the mean is the highest, so mean is greater than the median, and median is greater than the mode. And then when it is negatively skewed, we say that the mean it becomes the least, so the mode is the highest, mode is greater than the median, and the median is greater than the mean. Okay, so that's it. And then we also added that it's also help us to identify outliers in the data set, especially when we are using mean and median. And then also provides basis for further statistical analysis, particularly in terms of inferential statistics. Okay, let's say for instance, if I want to compare the mean ages of men and women in a switch class, I can do further and use a certain we call it t-test, okay, which is a more or less inferential statistics to provide information on the mean age of men and women in a class. Okay, good. So this is basically a reason we perform central tendencies. Okay, so we're going to take them one by one and talk about them. I'm going to take them one by one and talk about them. Okay, good. So now let's start with mode. Okay, mode is very easy one to do. Okay, so let's start with the mode. Okay, great. So let's see. Okay, so let's go this way. Let me enter. Okay, so let's say mode. Okay, mode. Now, when we say mode, please, what is it? When you say mode of data set, what is it? Mode. When you say mode, what is it? Mode. When you say mode, what is it?
Mode is the most occurring frequency in a data set.
Most occurring frequency in the data set. Okay. All right. Good. Okay. Good. What else again? So mode. It is the most occurring frequency. Okay. Most occurring frequency. No, this doesn't sound right. Most occurring
number.
Number.
Good.
Data. The data with the most.
Good. Number. Okay. Good. Almost occurring value. Okay. Value. Okay. Or what you said again, we can say that the word the value with the value with the highest frequency. All right, so we can make it that way. Okay, so good. All right, now can you tell me something more about a mode? Something more about the mode? Yes, when do we use it? Okay, when do we use it? Yes, when do we use mode? When do we use mode? Yes. Mm-hmm.
When the data is nominal.
Okay, when the data is nominal. Okay, great. Okay, good. Okay, so we use, okay, we can determine the mode. It doesn't matter the nature of data, but sometimes if the data is categorical, okay, if the data is categorical, if the data is categorical, we can't actually calculate the mean for it. Okay, all right, we can't actually calculate the mean for it. Okay, so which means that when the data is categorical, all right, the value, the only thing that we report, okay, is the what? Is the mode. Please, do you understand what I'm saying here? Because you see, if let's take it this way that let's take it this way that I have different shapes. Okay, let's say okay, so let's say, okay, so okay, when the data is what? If data is what? If we have what? When the data is okay, the data is categorical. Okay. All right. In that case, for categorical data, we can't report mean. Okay. What we can in this case, when the data is categorical, we can report it for all manner of data. But when the data is categorical, that is the only choice. Please, do you understand what I'm saying? We can do it for interval ratio data. We can do it for all numerical data. Okay, the nominal, ordinal, and all of them, all that. But when the data is categorical, that one we don't have any choice. Okay, the best central tendency we can perform, okay, is what? Is the mode. Okay, the best word, central tendency to perform, perform is the mode. Okay, there is no choice. All right, there is no choice at all. Okay, if let's take it this way that if I have a table, let me insert a table here. Okay, let's say if I insert a table, okay, let's say I insert a table like this. And here, let's say shape, frequency. Okay, so let's say square. Okay, square, let's say 10. Okay, rectangle, angle, let's say 12. Let's say circle 8. Let's say triangle, let's say 11. Let's say trapezium. Okay, trapezium. Let's say 10. And let's say last one, maybe cube.
10.
Cube is not really a shape like the amount of solid. Like so let's take it this way. Let's take let's say oval. Okay, like let's say oval shape. Let's say let's give it, let's say 9. So you can see that this data that I have here, these are nominal data. Okay, these are nominal data. So in nominal data, you can't calculate mean. You can't say mean shape. There's nothing like mean shape. Okay, there's nothing like mean shape. Okay, all right. There's nothing like median shape. No. Okay, so for categorical data, you even have no choice. All right. okay, what we can perform median, we can perform mode for numerical and categorical data. But when it is categorical, when the data is categorical, that one, we don't have any choice than to perform what? Than to perform mode. Because when the data is like this, you can't say median shape. Do you understand that? You can't say median, we can't say mean shape. No, there's nothing like mean shape. There's nothing like median shape. Okay, so in this case, what we can report is the word, the molder, okay, that the molder, okay, so what we can report here is the word, is the molder, okay, what we can report here is the word, is the molder, all right, so from this one like that, you see that we can report the word. So in this particular case, like, you can report the word, you can report the word, the molder word, the molder shape, okay, which is what? Which is in this, from my table here is what? It's rectangle. Okay, all right, rectangle. Are you with me? Okay, so you see, we can do it for whether it is interval ratio, okay, data, or nominal data. Okay, great. But what we are saying is that whether the data is what, so this one can be performed for both what, categorical data, and then the word, and then the numerical data. But when it is categorical data, we have no choice. Okay, all right. So we can perform for both categorical and word and interval ratio data. But what we are saying here is that if it is categorical data, there is no choice. Okay, there's no other choice apart from mode, because what is here? Okay, for categorical data, no, we can't say that median color, median shape. There's nothing like median shape. There's nothing like median color. There's nothing like mean shape. There's nothing like median. Okay, so in as much as that, we can do it for both words, both numerical, okay, categorical and word, categorical, okay, and word, and numerical data, okay, all right. For when it comes to categorical data, that is the only central tendency you can perform. Please, are we clear with that? Because categorical data, you can't say there's nothing like mean shape, there's nothing like median shape. No. So here in this particular table, what you can only report is the word. We can only report the word, the median, the modal shape, which is the word, which is the rectangle. Okay, please, are we clear with that? Okay, great. And
Yes,
and then another important thing with the mode is that what is the advantage of the mode? What is the advantage of the mode? What is the advantage of the mode? Okay.
it is easy to locate it when the data set is ungrouped.
It is easy to locate when the data set is what? Is ungrouped. Okay.
Yeah.
So the mode is quite clear. Okay. I mean, it's as you just said, it is easy to understand. Okay. Like, I mean, like it doesn't matter. Let me duplicate this slide and then take duplicate the slide and then take this graph, this one off here. Okay, great. So for categorical data, we talked about it, and then let's see the significance of that. Significance. Okay, so significance of the mode. Okay. All right. So here, okay. Oh, I think we just did one example. Okay. Okay. Well, let me add few. Let me add few examples. Well, let's finish the significance, and after that, I'll add few examples. Okay, great. So significance, okay, you can say that it is easy to identify, right? What about easy to? You can just say easy to understand. Easy to understand. Okay, it is easy to understand. I mean, if you really go to KG class and you put it there, if they should take the molder, Okay, what the concept is easy to understand. It's not something that you will struggle to understand the mood. Okay, it's not something you struggle to find it at all. Okay, it is easy to understand. And then another good thing about it is that it is not what it is not affected. It is not affected by the word. It is not affected by the outliers. Okay, so extreme values. So we're going to do extreme values. Okay, extreme values do not what? They do not affect the mood. Okay, all right, they do not affect the mood at all. Okay, all right, so it's the extreme. So extreme values do not, it doesn't affect the mood in any way at all. Okay, and it works basically. Okay, especially when the data, it is for both this and that. Okay, all right, good. But when the data is categorical, as we said earlier on, when the data is categorical, that is the only central tendency that you can actually perform. Okay, when the data is what is categorical. Okay, and then on top of that, we say that it is what we can perform it for both continuous for interval ratio data as well. Okay, but if it is categorical, you have no choice. That only mode that we can, because we can't perform what we can't perform mean and what and average and okay, or mean and what median for categorical data. Okay, so here, okay, so let me bring this. So mean and what median cannot be performed for categorical data. Okay, all right, great, excellent. So, and then it is easy to understand and it's not affected by what outliers. So I think I will use some example to explain the side, okay, what I mean by that. So let's see. So let's go to the old school, some simple calculations. So calculations on the word. So calculations, okay, calculations on the mean, on the mode, okay, calculations on mode. All right, good. So we are talking about what calculations on mode. Okay, good. So let's see the calculations on mode. So let's say if I give you data like this. Okay, so let's say example 1. If I give you 2, 4, 4, 3, 4, 7, 1, 1, 3, 4, 2, 5, 6, 4. All right, something like that. So let's say, so this one that I have here, so in each case we will do for group data. So let's say this is what this is ungroup data. So this is ungroup. Okay, so and group data. Okay, so for each case when we are doing it, we'll do for what? For ungroup data, and then we'll do for group data as well. Okay, all right, great. So let's say I have this data on my screen, and then I ask you to find the what is the modal number? What is the mode? What is the mode here? So so what is the mode? Okay, so let me use alphabet for this one so that it doesn't become confusing. Okay, so what is the mode? What is the mode here? What is the mode? Okay, what is the mode? So clearly the mode is what? Clearly the mode is what? The mode is equal to 4. Okay, good, excellent. And then if I also give you, let's say, let's go to B. If I give you B, some sort of what? I can give you some sort of group data. I can give you some sort of group data whereby the data is in what? It's in actually grouped. All right. Okay. So when we get to what? We get group data. Okay. I can give another form of ungroup data as well. Let's say if I give another one like this, I can give you another table form. So let's say insect, then we go to table. Okay, like this, like that. Okay, good. Let's say something like this. Okay, good. So here I can also give something like that. Let's say B. Okay, so let's say age here, and let's say frequency. Okay, it is still ungrouped. I've not put them into classes, so this is still ungrouped data. So let's take it this way: the age, and then I put here 1, 2, okay, 3, 4, 5, 6, and then I put here 2, 5, 3, let's say 8, 4, and let's say I have 1 here, like that. So let's take it this way, man. Maybe this is the age distribution as a children's party, like that. Okay, so if I have something like this, okay, so if I have the age distribution at children's party like that, and then clearly if they ask me to find a word, find the median word, this one up here like that. Okay, so find the median age. So from this data, from this table, okay, they've not grouped that. Okay, the data is what? It's still ungrouped. They've not grouped the data. Okay, they are not in classes. Okay, so when it comes to the group data, whether they put it in classes. So what I have here, like that is, if I want to compute for the mode here, simple. What is the mode? So you can see clearly that the mode is what? The mode is thank you. Okay, so the mode is what? From my table here, the mode is what? 8. Okay, sorry, the highest frequency. The highest frequency is what? Is 8. Okay, so the mode and this highest frequency match to what? 4. So 4 ES. Okay, ES becomes my mode. Okay, and what is the explanation to that? Because it is the age with the highest frequency, good or highest occurrence, that is being A. All right, good. So something like this. So this is for,
hello, sir.
yes, please.
Hello, sir.
I'm listening, please.
So in this case, will the question be like, what is the modal age, or what is the mode? Then you look at the frequency, you connect it to the age. Because if it's like, what is the modal age, then that one you can look at the frequency, the one with the highest frequency, and then you come out. But if it's what is the mode? If
no,
the mode, taking, you may,
the mode is also the same. When I say
okay,
that, if I give you age and I say what the frequency is only counting them, this can't be the mode.
okay.
So when you say the mode, you are referring to the age with the highest frequency. That's what it means. So it's not referring to the number here, no. Okay. So here I'm throwing more light on why the mode is 4 years. Okay. So let me. Okay. I'm throwing more light on this. So here this is not the mode. This is the count of these words of the ages. Okay. So when you say the modal age, okay, in fact, we'll be quite specific so that there's no ambiguity. Okay. I think I've told you that earlier on. Okay, good. So here you can see that the age with the highest frequency is the mode. So that's the modal age. Okay, it is the age with the highest frequency. Okay, great. So these two that I've done, all of them here, they are what? They are ungrouped data. Okay, good. Now let's go to a case with what? With group data. So let me duplicate my slide here. Okay, great. Now let's go to a case with group data. Okay, group data. Okay, group data. All right, so let me deepen this one a little bit. Group data here. Now, for group data, okay, so let's take it this way. Okay, let me. Okay, still the age of children at a party. Okay, let me still keep this one. Okay, so group data A here. All right, let me go back a little bit. Okay, great. Okay, so let's see. Let me take this one up. All right, so here in this case, I'll get to what in group data. Okay, what are you looking for? Group data, you see something like class what? Class interval. Okay, all right, great. So is age all right, but the age you'll be given in the form of what? Class interval. Okay, so here I can say that maybe I can say 0 to 9. Hello.
So is it the same as class boundary?
No, class boundary and class interval are different. I will explain them.
Okay.
I'll talk about it. Don't worry, I'll talk about it pretty soon. Okay, so do you know what? Let me delete this one and insert new one so that I can all of them here. Okay, so let's say okay, let me take big. Okay, that's fine. No, it shouldn't be too much. Okay, that's fine. Okay, great. Here. All right, good. Okay, so good. So let's take it this way, that class interval. All right, and then there's something we call class boundary. Okay, class boundary. Okay, so let me, because of the question that our brother said, let me take this opportunity to explain all of them here. And then class midpoint. Class midpoint. Okay, all right, good. Like that, okay. And then let me put maybe my, okay. Let's, oh, okay, you know, but let me put my frequency here because, okay, let's say, let me cut this and put it here. Okay, and then put this one here. Okay, and then put my frequency here. All right, good. So let's take it this way, that we've been given class interval, and the class interval goes this way. Maybe the class interval goes from 0 to what? 0 to let me okay, children's party. So children's party, I want easy one, children's party. Somebody should give me a ring. Okay, 0 to, okay, so all right, let me make it the people at
0 to 9.
Okay, 0 to 9. Okay, so let me put it this way. So 0 to 9 here. And then the next one, let me make it 10 to 19. Okay, 19 to 20 to 29, and 30 to 30 to 39. All right, good. So I have something like this. Now, so let me give my frequency to be, let's say here is a 4, here is a 5, and then let's say 6 here, and let me make here maybe 3. All right, something like this, great. So what is here is the class interval. Okay, this is the class interval, and with this class interval, the values on the left. Okay, so the values on the left, can I type? Okay, good. I can type somewhere here. Okay, great. So here, so the values are what? The values on, so this is the class interval, 0 to 9, and stuff like that. Good. Now, the values on the left, okay, the values on the left are the what? Here, those values on the left here, they are the lower class limit. Are you with me? Lower class limit. So the lower class limits are the ones on the what? On our left side, and then the one on our right side is the what? Is the upper class limit. Okay. So when we talk of the class interval, so here, and if I should take the, let's say the second class, okay, all right, remember they are in groups, so these are the groups. We've actually put them in categories, okay. So what is here is being categorized, okay. We put them into categories, we put them into groups, okay. So let's take it this way. Let's take group 2. If I put group 2, which is what? Which is 10 to 19, okay. The lower class boundary, okay, my lower class boundary, my lower class limit is the what? Is the lower class limit is 10, okay, all right. Lower class limit is equal to 10, and my what? My upper class limit is equal to what? Is equal to 19. Okay. Now, when it comes to what? Class boundary. Class boundary, you subtract 0.5 from here, and then you add 0.5 to this one. That's what you do for class boundary. But if it is 0, you don't subtract. You don't subtract from 0, okay? Because it will go to negative. So for 0, you don't subtract anything from 0, okay? All right. So if it is 0, we don't subtract anything from where? From 0. So here we add our upper class boundary will be 0 to 9.5. Okay, we'll still keep it this way. And then here you subtract what? You subtract 0.5 from here. Okay, so we'll get what? We'll get 9.5 to 19 to 19.5. And then the next one is what? 19.5 to what? To 29.5. Okay, and then the next one is what? Is 29.5 to 39.5. Okay, so when we do this, this is the class boundary. So in that case, okay, 9.5, okay, to 19.5, okay, 9.5 to 19.5, okay, here will give us, so this one will have what? We have the lower class boundary. Yes, please go ahead. Hello, go ahead with your question.
Yeah, under the 0 to 9.5, that is the first one. Some books, I don't know, some books, they will make it 0.5 before then 0.5. I don't know whether it's also correct or this one is also correct.
It depends on what is starting it. Okay, it depends on what is starting it. If what is starting, if it's 1, I can subtract the 0.5 from it. But if it's 0, you don't subtract. It will take you to negative.
So like this, you don't add the 0.5.
Like this? No, you don't. You
Yes,
add the 0.5 to the upper class limit.
But the lower class limit, you don't add it.
No, you don't add. Lower class limit, you subtract. Look at here. Okay. You see here is 10. I subtracted 0.5 from it. Here is 20. I subtracted 0.5 from it. Can you see that?
Where the 9.5 will also come down. That my problem is under the 0.5. It's 0 instead of 0.5.
No, it can't be 0.5. If you add 0.5 here in the lower class band, you don't add, you subtract.
Okay.
You can see all of them. It is in mathematics, that's consistency. So you are consistent. Okay. So yeah. So you
I'm applying the rule of mathematics. Thank you, Doc.
Yeah. So you subtract 0.5 from the lower class boundary and you add 0.5 to the upper class boundary. That's what you do.
Okay.
All right.
Thank you, Doc.
You're most welcome, sir. So with this one, with the lower, so here, the lower class boundary for this one is what? It's 9.5, and the word, and the upper class boundary is what? It's equal to 19.5. Okay, so for the class boundary, so please don't confuse yourself with the word class interval and class boundary. So class interval is what you are going to use. That's the original groups, the original categories that you have. Okay, but the class word, when it comes to the class boundary, that is where you subtract 0.5 from the lower class boundary, and then you add 0.5 to the upper class boundary. Okay, so here like that. So you subtract 0.5 here, but for 0 you don't subtract anything. Okay, for 0 you just keep it like that. Okay, good.
We say let's do some correction here with a class interval 30 to 39. Under the class boundary is supposed to be 29.
29. Great. All right, thank you. Okay, so from here, then what is class midpoint? So class midpoint, what you do is that you add this and this and you divide it by 2. Okay, so class midpoint, you add this and this. You add the lower class limit and upper class limit. You divide it by what? 2. So here, if I want to find a class midpoint, okay, all right, the class midpoint will be given by what? 0 plus 9, which will give me 9 divided by 2. That will give me 4.5. Okay, and then 10 plus 19, okay, that will give me 29 divided by 2. That will give me 14.5. And then here, this 20 plus, that's going to give me 49. So that will give me 24.5. And then here, automatically, you can tell it is 34.5. So this is the class midpoint. So for the class midpoint, what you do is that you add the lower class limit and the upper class limit, and you divide it by 2. So that will give you the class midpoint. Okay, all right, good. So this is, so basically, so here, if you are still using our one here, the class midpoint, the class midpoint here is equal to what? It's equal to 14.4, 14.5, sorry. Okay, great. So from here, let's say we want to know our word, our median word, our mode. Okay, all right, our mode. So when we come to our mode, okay.
Hello, sir.
Yes, please.
Please, the 9.5 will be 4.75. Oh.
Which one?
The first one.
You add lower here and then the upper here, and then you divide it by 2. Which one did you add?
The 9.5.
No, look at what, are you looking on my screen?
Yes, please.
You add lower class boundary and upper class boundary. You add lower class limit and upper class limit, and you divide it by 2. Not what is here, not this one, not here. That's not what we added. You add this, it's a class limit. So come to, so class midpoint. So this class interval here, the midpoint, this plus this divided by 2. Are you there? Hello?
Hello, sir.
Please, can you see what I'm talking about?
Sir, the screen is off. It just came back.
Okay, so what you do is that you are not adding the class boundaries and divide it by 2. You are adding the class intervals. Okay, you are adding the lower class limit and upper class limit, and you divide it by 2 to get a class midpoint.
Okay, sir. Okay, sir.
So you add this and that, and then you divide it by 2 to get a class midpoint. So
okay, sir. Thank you.
Great. So from here, what is our mode? What is our modal? So here you see that what I would ask is that I'll ask of the modal class. Okay, I'll ask of modal class. That's what I'm going to add. So what is the modal class here? What is the modal class?
20 to 29.
20 to 29. Okay, good. That's the modal class that I'm going to. Okay, so you can see that depending on where they are. So for group data, okay, they are not going to ask for a single value. Okay, all right. For group data, they are going to ask for what? For a class. Okay, good. So still on this one, we can.
Sir, please, I don't understand. I don't understand why the modal class is 10 to 29.
What do you think it is? What do you have in mind?
And I think it's not even 10 to 29.
It's 20 to 29. That's what he said.
So what do you think it is? You say you don't understand why.
No.
20 to 29.
I had 10 to 29. That's the reason I said I don't understand. It's 20 to 29 rather. I had 10 to 29. So I was after that.
Oh, okay. All right. So this is the modal class. So what is here is the modal class. Okay, great. So another thing about the mode that we can also do is that apart from this modal class, okay, we can also use the mode, okay, to we can have what and so we've done mode for what? For group data, and we've done it for group data. and quite straightforward. Another calculation with mode that we can also do is where there's a histogram. Okay, so you see when the data is continuous data, okay, or we can transform it to continuous data like the one we have here, okay. You see, we can have something we call what we can use it to construct what histogram. And if you look at the data carefully, you could see that the lower class boundary here is the upper class boundary there. Okay, so your lower class boundary is someone's upper class boundary. Your lower class boundary is the next person's what? Your upper class boundary is the next person's lower class boundary. So you can see from here, this idea. Okay, so like that. So with this one, we can use it to construct frequency histogram. Remember, histogram, we can only construct histogram for what? For continuous data. We can't construct histogram for categorical data. We can only construct histogram for continuous data. That is the interval ratio data, like marks and age and stuff like that. And when we are doing that, we use the class boundary, okay, for the construction of what? Of the histogram. So we are going to see how we can also get histogram. So mode.
Please, I have a question.
Go ahead.
Okay, please, can we go back to the table? Yes, please. Yeah, please. Let's take it that with the modal class. In fact, when we take the frequency, now the frequency, we want the modal class, but the modal class appears twice there. So let's take it that we have 4 twice. Yes, please.
It's if the modal class appears twice.
Yeah, like let's take it for example.
Okay, that's
yeah. Appearing twice.
Yeah. In
the frequency.
Yeah.
Yeah.
So like we are talking about maybe here also. Let's say here is also 6, right? Is that what you're talking about?
Yes, please. Yes,
okay, that's fine. Okay, great. Good. What happens? You report both. So in that case, one of the disadvantages of mode is the fact that, okay, it's not always unique. That's one of the disadvantages. It's not always unique. Sometimes you can't even get mode at all. Okay, we can't even get mode at all. I can give you data like this. Let's say okay, so let me duplicate this one and then let's take it this way that let's take it this way. If I ask you to find the mode of this 10, 12, 18, 17, 15, 20, like that. What is the mode?
No mode.
Yeah, so here there's no mode.
Yeah.
There is no mode. So it's not always we can get a mode. And then B, we can also, it is one disadvantage, okay, of somebody's making noise here. Let me please one disadvantage is that one disadvantage of mode is that, okay, it's where we can get by mode. It's not always unique, and because it is not always unique, we can even get multiple mode. Okay, let's say if I give you something like this, okay, if I give you like this, like this, and I ask you to find the mode. What is the mode there? You can see that the mode is what this particular graph. This
10 and 11.
So you can see that the mode the modes are what? We have the word 10 as well as what 11. So this data set has two words. So the data has two modes. And so when the data has two modes, like we can say it is what? It is bimodal. Okay, so that's a bimodal data. Okay, so one disadvantage. Okay, one disadvantage of what? One disadvantage of mode is the fact that it is not always unique. Okay, all right. Sometimes you can even get mode and then you can get 3 and stuff like that. Okay, great. So one disadvantage is that, so let me add this one to it. Okay, so okay, one. Okay, so okay, good. I can just say that mode is not always unique. Okay, mode is not always unique. All right, because you can even get trimodal, you can get bimodal. It's not always a single value. Okay, all right, good. So yeah, so when it happens like that, it means that when you draw the graph, if I should draw such a graph, okay,
Hello, Doc.
yes, please.
My network is breaking. Please, how did we get the 110?
Oh, it's me
So
that
please, the mode to be 10 and 11, but you made it 10 and 110. So can you
No,
correct
it's
that?
my typo. It's my computer. When I'm pressing, see the computer, the keyboards are big. So see that most of the time, when I'm typing, I make a lot of. Sometimes I press 2 keys at the same time, so it's just a typo. Okay,
All right, thank you.
Thank you. So let's say that one, when you draw the graph, you see things like that. You see sometimes you see something of this nature, like that. Okay, so when it is something like this, so this is a bimodal graph. Okay, which means that the mode is not where it's not one. Okay, so you can get, it's not always unique. Okay, because you can get bimodal, you can get trimodal. Okay, data. Okay, great. All right. So another thing we could do. So now we are done with this side. I hope this side is clear. So it is possible for us to get a trimodal, bimodal, even tetramodal. Okay, depending on the nature of the data. So it's not always that the mode is unique. It's not always unique. Okay, we can get bimodal, we can get trimodal and stuff like that. Okay, great. So the next thing that I'm going to talk about is what? So we're going to talk about mode in histogram. Okay, so we know that from the group data we just did, okay, we can construct this beautiful table. Okay, so let me take this. Okay, you know what? Let me change the layout first. Okay, so let me reset the layout. Okay, like this. Okay, all right. So, all right. Okay, great. Okay, so here, all right, we are going to bring our data here, and then we'll see how we'll draw our histogram here. Okay, so let me stretch this one a little bit. Okay, so let me bring the data, this one here. Okay, okay, all right, good. So let's say I have, let me bring this data here like that. Okay, good. Compress it a little bit. Okay, okay. Let me delete this one. Okay, so okay, it's difficult to take it out, so no problem. Okay, great. So all right, so let's say I have this data here like that. Now, when you draw your histogram and you finish drawing your histogram, let's take it this way that let me make a rough sketch of histogram before we come to this data. So I have my histogram here. Okay, so let's say this is the histogram like this, like that here. Okay, this is my histogram. So the frequency is here, and then the word, the mark is here. Okay, the frequency is here, the mark is here. Okay, so this is the frequency and this is the mark. So what is going to happen? So you draw. So first of all, you draw this. Okay, you draw that. Okay, I'm not drawing for this one. I'm just giving the general one before. Okay, draw that. Okay, maybe draw another one. Okay, another one like this, like that. Then draw another one like this, like that. Okay, draw another one like that. Okay. Like that. And then they can ask you after you've plotted your frequency. So I'm not drawing for this one I have here. After that, we'll use the data to do it. So let's take it this way that let's say this is my, let's say here is 4.5. Okay, here is let's say 9.5. Okay, here is here is let's say so interval of a word plus 5. So here is 14.5. Okay, here is here is will be what 19.5, and then 24.5 here, 24.5. All right, great. Now, when you are going to trace your so with this one, with histogram, they can ask you to find a median mark, not median class. Okay, with histogram, you can be asked to find the median mark. So what you do is that you look for the median bar, I said sorry, modal you can ask you to find the modal mark, okay, from this one. And what you are going to do is that you look for the modal bar. So of course, this is the modal bar, okay. So what you do is let me pick different color. So what you do is that you use your ruler after you've drawn your histogram like that. Then you use your ruler to project. You draw this line here, here, here to the adjacent bar close to it. This one here, and then you draw another one from this side. The bars close to it like this. To this corner here. Okay, so you draw broken line like that to this corner. So where the two lines will meet, then you project it down with your ruler. Like that, like that, like that, like that, like that, like that, which will all the way to the point here. So I assume that let's say if here is 9.5, so let's say the gap here is 5. So maybe here is 2, or maybe 1.5 here. So we add 1.5 to this one, and that will give out what 11. So what I have here, which means that from that, okay. From this table, I can say that what I can say that from the table, from the histogram, okay, that way the median, the mode is what is 11. Okay, so you trace it from here. Okay, so this is your bar. So you look for the bar adjacent to the word, the modal bar. So this is the modal bar. Then the modal bar, those two bars adjacent to it, you draw one from this side, from the corner to this one, and you draw the other one from the corner there, and then you project it down. And then when you do that, you use it to trace your modal mark. Okay, are we there? Are we clear with that? Okay, good. So let's see. We are going to do it for this data. Okay, so you are going to do it for this my data on my screen, and let's see what we're going to get. So I'm also going to take a sheet of paper, and then we'll do for this data, and then we'll see how it looks like. Okay, all right. Good. So let's do it quickly, and let's see what we're going to get. Okay, then also take a sheet of paper. So you are going to plot this histogram, and please, when you are plotting, remember that here will be the word, the down here will be the class. Okay, the way what you can also use, apart from the class boundary, you can also use class midpoint to do it. Okay, you can also use class midpoint to do it. Okay, but the ideal one is a class boundary. So here you use what, 9.5. Okay, then 9.5 here, so 0 to 9.5. Okay, all right, and then the next one is what, 9.5 to 19.5. So like that, okay, onwards. Okay, and when we finish, we trace our. So do you know something? Let's see whether I can add one more. Okay, this one. Let me see. Can I increase the table? Oh no, it won't allow me to increase it. Okay, so let's assume that I add one more. Okay, all right. Let's keep it like that, and let's start. So let's take a sheet of paper. Let me take a sheet of paper and see whether I can draw something. So let's all do it and see what you are going to get. What the median, the modal mark on the histogram is going to be like. So rough sketch here. So the next one, okay. So I have my 9.5. The next one is where it's 19.5. The next one is the next one is 29.5. The next one is where it is 39.5. So frequency here is so it goes up to, okay, so frequency is here, and then this side is 4.5. So let's say we'll make this one 2. Okay, so let me make it let me draw it. Please, are you all doing together? Are you all doing together? Please, I want to see everybody doing it, please. We're all doing it. So I've also taken my ruler. I'm also doing it here. Okay, after that, then we compare our answers, okay? Okay. Okay. The highest number is 6. Let me see. 1, 2, 3, 4, 5, 6. Okay, so let me make it 1, 2, 3, 4, 5. Let's say 6. 6 here. So first one is what? Is 4. 1, 2, 3, 4, 5, 6. So first one is 4. Okay. Who is done? Who is done? Next one is 5.
I'm done.
Okay. What is the modal mark you had when you trace your values?
Yet to do that one.
Yeah, yeah, yet to do that one. Then the next one is 6. And the next one is 3.
Please, I'm done.
Okay, great. So what is the modal stuff that you had?
I had 22.5.
Okay, so let's see. Okay, so let's also finish ours and compare it to your answer. Okay, and then so that's 9.5, 14.5, 24.5, 34.5. Okay. Oh, was it 14.5? Okay, no, just 4.5. Oh no. It's 9.5. 9.5, 19.5, and then 29.5, and then the 39.5. Okay, great. So from here, I'm going to trace my modal. Okay, good. So if I trace it correctly, let's see, where am I gonna land? Okay. Okay, so the interval is about it's 10. So okay, so 10. The interval is 10, and so let's say if the interval is 10 and I'm here. Okay. Okay, so maybe if I use my eye. Please, what did you get? You said you had what?
22.5.
Okay, I think so. Okay, maybe take it.
Sir, I also had 21.5.
Yeah, so it will be within that range because most of us are not using
21.5.
You're not going to get the same thing because you're not using graph.
We are not using graph sheets. Okay, so that's
Yeah, we
fine.
are not using graph sheets, so that is how it will be.
But I will pick my lady's answer as a good standard.
For mine, I use graph sheet.
No, sir. Oh, my lady used graph sheets. So if those of you didn't use graph sheets, you are wrong.
No, sir, how can you know that she used graph?
She used graph sheet. I trust her.
Oh, I use it. I can snap on
My dad explain.
Hello.
Hello.
Hello. Yeah, I also use a graph sheet. A young man, so he's 22.
You have 22.
22.
And then my lady had what?
22.5.
Then let me see. Let me look at mine carefully and see.
Okay.
Whether
Okay.
I think I will. Maybe my hand, man, our hand is not as straight. I will still stick to my lady's answer. Yeah, I'm not going to change my mind. Okay, I'll still stick to my lady. I will. You know what? I'm taking a picture and show you what I had here, and let's see whether.
Sir had 21.5. I know. I can.
Sir, what's your name? Sir, what's your name?
Oh, for my
no.
The thing is that
We had 21.5.
Oh, look at you. Let's see what I had, and then we'll compare to that of my lady because she used graph sheet. Okay, so
Play it down.
Let's see.
The protagonist down. The protagonist down. The protagonist down.
Let me see what I had, and then compare. Don't worry, we want to compare. Hello, please, I'm listening to you.
Which one are we adding?
We are. So you use it to trace. So you come here, use it to trace here. So you trace here, and then so if I using graph, it will be at a
I did your courses here. Martin.
The intersection of the diagonal from the highest bar.
Does it will be between 19.5 to 29.5?
Yes. I'm coming to share mine. Let's see. Let me go to, let's say, I want to see how we share this one quickly. Okay, let me pick this one here. Okay, so that we'll see my answer and see. But I think I will still go with my lady's answer. No matter what, the ladies are right. So
And doctor, when you even use the formula for the group data, you get it.
oh, is that so? Don't explain yourself. Me, I trust you. Whatever you say is fine. Your answer is fine. So let's see. Let me try and get. I want to. I'm just sending it to my screen and then I've just WhatsApp it to myself. So I want to pick it from there and then I'll add it to my slides here. Let's see. Okay, so let me duplicate this one here and bring mine. Okay, so let me take this one away. Okay. All right, so let's see. Here we go. WhatsApp online and see. Oh, it's still loading. Okay, good. All right, so it will be close to what the lady had. But if we're using graph sheet, that one, everything is going to be quite clear. Okay. So I think I didn't straighten my hand at some point. So that's why my lady, you said you had 22.5, right?
Yes, please.
No, I think your answer is right. Okay. Don't mind the man. Okay, don't mind it. Okay, don't mind that.
Then show us the formula. You said when you use the formula.
There's no formula.
I'm
not using formula. You trace it from the graph. You trace it. You are not using formula here. You trace it from the graph. So I'm going to. The thing is loading. So I'm going to. You don't use formula. Okay. In there's every formula you need. I'll give it to you on the exam sheet. Okay, because I don't expect you to memorize formula and stuff like that.
Thank you.
Yeah, because this is 21st century.
I want to ask question.
Please go ahead and ask question. Okay, why I try to load.
Like in drawing the histograph, I want to know if you use a scale like the frequency one.
Yes, you have to use everything should be standard.
Okay,
so when you use so let's see. All right, so let's see here.
You come with some 4-figure tables.
Sir,
okay, great.
Then in the other, are we going to use graph?
Yes, you need graph. You'll be supplied with graph.
Okay.
Okay. Definitely one question will come for histogram. Question will definitely come from histogram.
It. So we are aware, and that is what I wanted to.
No matter what, histogram, no matter what, question is coming. Okay. Oh, the thing is still, why is this thing taking so long? Okay, so I'm trying to get it here. Okay, so okay. I've loaded it, but I'm just trying to project it and then it's a little bit slow. Okay, let me see. Hi. Okay, let's see. Why is this thing taking so long to display? With the internet, all right. Okay, let me copy it here and see. Let's see, I've copied it there. Let's see whether it works. Okay. Okay. All right, so let me rotate it. So let me rotate it this way. And then, okay, like that. And then crop the side. Okay, like that. Okay. Good. Okay, great. So this is my histogram. So the reason that I picked my lady's answer was that, you see, this is my 19.5, and you can see that coming down here, my hand wasn't all that straight. Okay, so my hand is not as straight as the lady. So if I should have come down here, that I would have gotten 2 plus 2 here. Okay, 2 more. So here is 19.5. I would have gotten like more or less like 2. And then so that would give us maybe like that. So I mean, I couldn't really project. Okay, if I just my drawing, they were not that straight like that. So I will pick my lady's answer. Okay, so my lady, please, what is your answer? Don't mind the man.
22.5.
Whatever you say is fine now, please. So the mode is already.
Thank you. Thank you.
25. Okay, very good.
Hello,
So,
sir.
yes, please.
Hello, sir.
Yes, please.
Sir, please, can I ask a question?
Yes, please. Go
In
ahead.
fact, yeah, I had some issues with my network, so I didn't get it. Now, looking at your own, the values that you use, that the frequency and the mark. Did you give that, or you picked it from the table, which is already there?
This is the table.
Okay,
This is the table.
So the 9.5 mark, 9.5, 19, that is the lower class boundary that you used, right? And is that the value that you are supposed to use always?
Yes. So here,
9.5.
I use both. I use both. It is 0 to 9.5. So 0 to 9.5. Hello. It's 0 to 9.5, and the other one is 9. And it's 9.5 to 19.5. You can see that the second one is 9.5 to 19.5. Just that your upper class boundary is the next person's lower class boundary. Okay. Have you seen it? So if you look here, 9.5 here, your 9.4, which is upper, is the next person's lower. Okay, this 19.5 here is this next person's that. So yeah, so in that order. Okay. Don't forget.
Then what about the frequency? What about the frequency? The 1, 2, 3. The 1, 2, 3. That 1, 2.
The frequency.
What? 1, 2, 3. On the frequency, was it created, or you chose based on the scale that
yes, it's based on the scale.
You have them from the frequency. Check the frequency.
1, 2, 3, 4, 5 is
check
based
on the
scale. 1, 2, 3, 4, 5 is based on the scale. So if you are plotting 9.5, you know it goes 0 to 9.5 is 4. Right?
Okay.
And the next one, this one is 5. So 9.5 to 19.5 here is 5. And then this one is 6. Then the other one is 3, like that. And then so right now we know that the modal mark will be here. Okay, will be within this bar. How do you get it? You place your ruler, and then you draw a hidden line from this edge of the bars close to the median like that up, and then this one this way, and then you project it down. So when you project it, the value you get here, that becomes the word, the modal mark. Okay, all right, that's for histogram. Great.
Hello, doctor.
Yes, please.
What if the modal bar, the highest bar is at the last, is at the end? Let's say with what you've posted on the screen.
Yep.
What if
that's the most beautiful question. Do you know why?
What if it's at 29.5 and then 39.5? What if it is that bar?
Yes, honestly, I've never come across such a question before. This is the most beautiful. It's true. Okay, when it is like that, what do we do? Okay, let's see. If the which means that it is heavily skewed. Okay, when it is like that, what do we do? Okay, let's see. If it is this bar here, what do we do? Which means that we can't. We can't determine the class with that method. We can't. Okay. Yes, if it is like that, because which means that there is no other bar here that we can project those adjacent stuff. So in that case, when it happens like that, we can only tell the modal class, but we can't determine the modal mark. Do you understand what I'm saying here? What I'm saying here is that for us to get the modal mark, we need to draw these two lines. We need to identify the modal bar, and then we draw on the adjacent from this side, the adjacent bars. We draw one from here to the top corner, and then another one from here to the next top corner. And then where they intersect, we project it down. And then our lady asked this beautiful question: that what about if the modal class or the modal bar happens to be 29.5 to 39.5? When it happens like that, what are we going to do? In that case, we can't determine the modal mark. We can only determine the modal class in that instance, because we can't draw adjacent stuff like that. We can't draw these two lines to intersect. Okay, so in that case, we can only get the what? We can only get the modal. Okay, we can only get the modal class. Modal. Okay, thank you. Please mute your mic. Please mute your mic. All right, good. So that is that. Please, any headache so far? That's a very beautiful question. That's a very good question. Good. Well done. Okay.
Hello, sir. Doc, please.
Hello,
Doc,
sir.
please.
When
drawing the histogram, is it only the class boundary you can use, or you can also use the class midpoint?
You can use a class midpoint. When you use a class midpoint, where will you put the numbers? When you use a class midpoint, where will you put the numbers? You can use a class midpoint, but where will you place them?
In the middle.
In the middle. Okay. So when we use class midpoint, we will put we won't put the numbers at the end. We'll put them in the middle of the bars. Okay. So let me write that. Okay. So when we plot with class midpoint points, the values are placed in the middle of the bars. All right, great. So we can also use midpoint to do the plotting, but when we do that, we are going to place the values in the middle instead of putting them at the end. We will put them in the middle of the bars. Okay. All right. Good. That's a very nice question. Well done. Yes. Any other question, please? Any other question before we go to that?
Hello, sir.
Yeah, please. I'm listening to you.
Hello, sir.
Please, I'm listening.
Please, my question is that in an exam, are you going to be instructed whether to use a class midpoint or it's your own choice? Either the class midpoint or the midpoint.
Yeah, it is your own choice. I think it is your own choice because you get the same answer. It doesn't matter which one you use. It's up to you, the one you're comfortable with. Okay, but you need to construct the table like this first. You need to construct the table like this first, and then sometimes, depending on nature of the question, sometimes they can give you this one and they will ask you to calculate mean as well. And you see, mean, you are not going to mean you use for group data like this. Okay, mean you are going to use a class midpoint as your X value. So in that case, okay, in that particular case, it is you have your class midpoint already there, okay, and then you can use it, okay. But it is up to you, okay. It's up to whether you want to use class midpoint or you want to use the class boundary. But usually we use the class boundary. But when you use the class midpoint, it's excellent. There's nothing wrong with that, okay. Just that they should be consistent. Saying that you are going to use graph book, so everything will be very clear there. Okay, there won't be any ambiguity. Okay, at all. Okay, all right, great.
All right, sir.
Well,
I have a problem.
Please go ahead.
Please, how did you get a class boundary? My network was not stable, so I didn't get that.
So you subtract 0.5 half from the lower. This part here is called lower class boundary. And then this side is called upper class. This part here is called lower class limit. The boundaries are here, okay? So this is the lower class limit, and this side is the upper class limit. So what you do is that you subtract 0.5 from the lower class limit, and you add it to the upper class limit, okay? But when there is 0 here, you don't subtract from 0. If you subtract from 0, it will go to negative. So 0, you leave it like that. Okay, all right, good. But you can see from here that we subtracted 0.5 from 10 and we had 9.5. We added the 0.5 to 19 and we had 19.5. So you subtract 0.5 from the lower class boundary and you add it to that of the upper class boundary. Okay, good. So that's what you do. So you can see that we subtracted 0.5 from here and we had 19.5, and we had we added the 0.5 to the upper class, we had 29.5. Likewise this one. So this is how we create the class boundaries. Please, are you clear with that?
Okay, sir.
Please, when we have to work for the mean, then we can use the formula, right?
You don't need to. Which formula are you talking about?
The sigma fx divided by the sigma.
No, but we've not talked about mean. We are talking about mode.
We are doing mode, and you are talking about.
Please, we've not come to that one yet. We'll come there. It's gradual process. Okay, let's go step by step. Okay, not all my people are mathematics inclined, so we are going step by step. So we are now on mode. So mode, we've done the 3 main steps. We've done for mode forward for okay, so here the disadvantage here, we say that it's not always unique. Okay, all right, good. And then we also made mention that we started with a calculation here. So for ungroup data, okay, we started with ungroup data. So something like this. Okay, the mode is what, 4, and then we can also get ungroup the age like that. And this one, they are not in groups. Okay, so this is also ungroup data. Let me increase the size a little bit. Okay. Okay, great. Okay, good. And then drag this one back. All right, great. So like that, yes, please.
Can I ask a question, please?
Please go ahead.
So what is the difference between the mode and the bimodal?
Bimodal, from the word bimodal. Okay, so please, are you paying attention to the class?
Yes, please.
Because I've talked about this one already.
We just break us off.
Oh, okay, I get you. So here, if you look at this one, you see, okay, so let me go here. Let's say if I have something like this, 10, 11, 10, 10, 11, 12, 13, 14, 10, 18, okay, let's say 9. Okay, great. So here, this one, like, if they ask, what is the mode here? What is the mode? The mode is equal to what? Hello, what is the mode here?
10.
It's 10. So you can see that in this data set, the mode is what? The mode is, so if I should draw for this data, let's see. Okay, so for the mode here, like this, okay, like that. So this one, like that, okay, you can see that it's unimodal, okay. This one is only one, okay, only one, okay, so only one data like that, okay, like only one. I could draw, if I draw, it's only one mode, okay, like that. The mode is one. If you come here, the bimodal, if you come here, you can see that the highest here, we have 10 is appearing 3 times, 11 is also appearing 3 times. And so with this one, which means that the modal word, that we have 2 modes. So in this case, this data is what? Is bimodal. And that's what makes that's the disadvantages of mode. Mode is not always unique. Sometimes you can get more than one mode, okay, for a data set. So when you get more than one mode for a data set, then if there are 2, if the modes are 2, that's a bimodal. You can even get trimodal. So here you can see that the mode here, this 10 appeared 3 times, 11 also appeared 3 times in the data set. So when you ask us to find the mode, we have 10 and 11. And so in this case, the mode, the distribution, the graph, we should draw the distribution graph, is going to appear like this. Okay, the modes are 2. So when the modes are 2, we describe the data set as what? As bimodal. If they are just only one, like this one. In the case of this one here, no mode. There's no mode here. This here, no mode. Here, the mode is only one. So it's unimodal. Okay. If the modes are 2, bimodal. You can even get 3, trimodal. Okay.
Thank you, sir.
Okay, good. So I think we are all clear with our histogram, okay, and how to find a class system. But do you know something? I don't want us to just now. Do you know what? I just have to be sure whether you guys have understood it. Okay. So what I'm gonna do is that I'm going to give you data. Okay, I'm going to give you data, and then you are going to solve it for me. Okay. Now, do you know what? Maybe at the end of it, when we give a break, so that we'll use that one for. Okay, because I just have to make sure that because no matter what, graph question is coming. No matter what, 3 graphs. Okay, 2 of them will appear. 1 of them will be compulsory. So there's no way out. You can no matter what. Please make sure you master them. So, but we'll do it. We'll do a number of them so that you master them before. Okay, good.
So
now
we said 3 graphs will come.
You say, well, there will be 3 graphs here.
Yeah.
But one of the graphs will be compulsory. So no matter what you do.
Oh, the graph will be compulsory.
One graph will be compulsory. Okay. Yes.
Okay.
And then you have option to choose. So we'll do cumulative frequency curve as well. Okay. Yes.
Okay.
That one. So there are 3 graphs. Okay. So the 3 graphs, histogram and cumulative frequency. Definitely one of them will be compulsory. No matter what, okay, whether
so it means whether compulsory one,
yes, whether a Noah's Ark comes or what, or his postponed rapture, whether it comes or not, there will be graphs on the compulsory graph on the paper. Okay, good. So the next thing that we're going to talk about is what we are going to talk about the median. Okay, all right, good. I hope we are clear with the mean. Okay, you can see that with the mode, you see the mode is not affected by what? The mode is not affected by the extreme, okay, all right, extreme data. If you guys could remember, you see, if you look at what we did here, if you look at our calculation that we did, okay, you can see that even if I put something like, 90 here, the 90 is not going to affect anything. It won't affect the mode. The modal value in any way. Have you seen it? It's not affected. So mode is not affected by extreme data. Extreme data doesn't affect the mode. Okay. If I put here even 10,000 here, okay, 10,000 here, okay, it wouldn't affect the modal value. Okay, so mode is not affected by outliers. And you can see that this is completely outlier. It's something that, like for instance, you can see that when I was typing, let's see, when I was typing this answer, I mistakenly typed this. Okay, now let's take it this way, that this one here, in my data set, I have something like this in it. Okay, that it was typed mistakenly. This mistake wouldn't affect the mode. It wouldn't affect the mode at all. Okay, so it's not affected by the word. It's not affected by outlier. So clearly, what I have here is an outlier. Okay, what I have here is an outlier, but it wouldn't affect it. What I have here is an outlier. Looking at the nature of the data set, and this one, you can see this is extreme value. You can see maybe the 9 that they mistakenly type it 90, or 11 that they mistakenly type it 110, but it wouldn't affect the mode. Okay, the mode is not affected by the word. It's not affected by outliers. Okay, great. Now, the next we're going to talk about is the what? Is the median. Okay, good, median. Okay, good, median. Okay, so somebody should tell me something about the median. What is it about median? Okay, what is median? When you say median, what is it? Yes, median. Okay, median. Yeah, somebody should help me. Yes, please.
So, okay, when we talk about the median, we are talking about the set of variables.
Mm-hmm.
The set of variables that are in the middle when arranged in order of magnitude.
Okay, excellent. So which means that we are talking about what? So the key points we're talking about middle value. Okay, middle value when they are what? When the data set, when the what? You said middle value when the data set, okay, is what? It's arranged. It's arranged in what? In increasing of
order of magnitude.
okay, great. That's it's arranged in what? Okay, in what? Increasing order of magnitude. I think your definition is excellent. Magnitude, excellent. Okay, all right, good, beautiful. So here, middle value when the what? The data set is what is arranged in increasing order of what? Magnitude. Okay, all right, great. So that's a middle value. Excellent. Okay, so now with this one, okay, my question I want to ask is this. I want to ask this question, okay? I want to ask this question. So how do we, the first question I'm going to ask is that, how do we determine the what? The median, okay? How do we determine it? Okay, so so let's say the second one, before we go to the advantages. So determination of median, okay? Of median, okay? All right, great. Okay, so let's take it this way. I think this one is the old school one, so we all know this one. So let's take this. I have 1, 2, 3, 4, 5, 8, 9, like that. Okay. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay. Okay, great. So with this one that I have here, this is straightforward. Okay. You can see that the number of what? The number of values that I have is what? Is odd. Is it odd number? So that's odd number, right? Odd number. Okay. Is that not it?
Yes,
if you count them 1, 2, 3, 4, 5, 6, 7. So if it is odd number, it's very, very easy. Okay. All right. Okay. So it is, if it is odd number, it's very, 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 very easy. So in this case, clearly, because what I have here is already arranged, what's my median? So my median is equal to what? It's equal to 4, right?
Yes, sir.
Okay, great. Now, what about if I give you a case slide whereby I give you, say, 8, 6, 7, 9, 3, 1, 12, okay, 17, 1, 2, 3, 4, 5, 6, 7, 8, okay, 10, like that. Like if I give you this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, like that, and I ask you to find the median. Please, what are you gonna do? Tell me.
You first have to arrange them in order of magnitude.
All right, so do it and tell me the answer.
So we have 1, 3, 6.
So we have 1.
So do it and tell me the answer. Yes.
The answer is 8.
Okay. 8. Okay, so let's do it together now. So when we do it together, we are going to get what? We are going to get 1, 3,
6,
7.
7.
Where did they come on? The 3. This one again.
1, 3.
It's 1, 3, not 1, 1.
Okay, then 9,
10, 12, 17.
10, 12, 17. Okay, so when it's like that, so we count the exact middle number is what? Is 8. Okay, oh yes. So the median equals what? 8. Okay, good. All right, so that is when this is. So now let's see another case whereby we have something like that. 2, 3, 4, okay, 6, 9, 15. Okay, something like this. And then how do we find the median in this case?
Sir,
Yes.
Sir,
if you look at it,
you add
you add the two middle numbers together and divide it by
middle numbers and divide it by 2.
So when we have this one, so in this case, because the total numbers, that's even, the total number is even, okay, even number, okay, so here we'll add the two middle numbers here, okay, so we should have what? We'll have
10 out of 2.
okay, so what we're going to do is we'll get to it. We'll get 4 plus what? 4 plus 6, okay, all divided by what?
2.
All divided by okay. 2 there, okay. Then let me put here, so that will give me 10 divided by 2.
Plus 5.
Here again, and then the answer is what? The answer will give me what? 5.
5.
Okay, so here, let me underline this to look like a fraction. Yeah, like that. And the answer is 5. Okay. So here we'll pick these two numbers and then we'll add them and then we'll divide it by 2. Okay. This is very, very simple. Okay. This is very, very simple. Okay. All right, great. Okay, now for median, we have a lot of work to do. Okay, so let's take it this way there. So what we have here is very simple. What about, let's go to the table form of data. So let's say I'm going to take this my table here. Okay, so let me bring this my table here. All right. So
Sir, please, I have a concern.
Go ahead.
So let's go back to the previous slide. Yeah. So you could see that the number that they give us is not 5. But when we added 4 to 6, we had 10 divided by 2. That one gave us 5. So in such a situation, how do you determine your median? Or you pick the two numbers?
Come again. Which one are you talking about?
Now, what I'm saying is that the numbers, this very one that they give us. So the median is 4 plus 6, which is 10. Then you divide the 10 by 2, it gives us 5. But when you look at the numbers there is no 5. So I am asking, in such a situation, what do you do?
If the 5 is still the answer. But it's not a matter that the number should be there. If you ask to find the mean age of the people in the class and you calculate it and then the mean age is 11.2. And then you say that there is no 11.2 in the data set, so the answer is wrong. No, that's the answer. You calculated it. So because they are middle, you pick the two middle numbers and then you add and divide it by 2. So that is the answer. So that's this 5 becomes what? 5 is our median. Okay, is the median. So you leave it. That's correct. Okay.
Thank you, sir. I just want to ask something.
Go ahead.
For my understanding, I know that when we use when we divide the answer by 2, the answer that we get we use to determine the position of that number. So the 5, I'm thinking, is it the position of that number that give us the 5, or the 5 as the answer?
What is here is straightforward. I know what you are referring to though. The position is straightforward here. So median is position. Median is a positional value. Okay, we said middle value when the data set is arranged in increasing order of magnitude. So it's positional value, it's position. That when you arrange all the numbers, the middle number. So here, when you arrange all these numbers, the middle number will be here. The middle number will be 5. That's what it means. When you arrange all this, the middle number is 4. When you arrange all that, the middle number is 8. So median itself is a positional value. It's a measure of location. You understand that? Let me add it here. Okay. It is what? It is a measure of what? A measure of location. A measure of location. Okay.
Yes.
Yep. So it's position.
Can I
go ahead.
Like what my brother is asking. That one can be possible with a group data.
Yeah, so that's what we can see that we are going to step by step. So we don't want to jump again. Okay, we are going through step by step. So you see that I went there to go and copy this. Okay, so we are going step by step. Okay, it's not necessarily good. We can even use it for group data, like the one I'm bringing down here. Okay, so let's do it step by step. Okay, all right, good. So the next one, okay, so this one is just this. So let's go to the table form of data. Okay, when we get the data in the table form, this one here, okay, like this. All right, so median word, median calculation. Okay, so median calculation here. Okay, great. All right, so let's see. We have this one here. Now let me bring this my age here. All right, great. So this is the one here. So we have what? So this is still ungroup data. So let's still ungroup data. Okay. All right, but it is in the form of what? Frequency distribution table. It is still ungroup data. So let's see whether we can do some calculation on this side here. All right. So in this case, in this particular case, okay, please just a minute. Please just a minute. My niece is calling me. Okay. Hello, Winnie. Good morning. Yes, I'm. Okay. Okay. All right. Good. So okay. So you are the pass by. Okay. Right. Okay. Thank you. Good. Bye. Okay. So yeah. So please you know our overpampered nieces and nephews, they just reported to university, and they think at every minute they can call the uncle. They will start the quizzes and then they will see their smoothness level. All right. The first quiz, no, they will change. When they even see my call, they won't even pick. All right. So let's take it this our data set here. So let's say we have data like this, and then we want to calculate for. So when we come to group data like this one, let's try to adjust the values a little bit so that let's see. When we add everything, what are we going to get? When we add everything, so that when we add everything, what are we getting? When we add everything, what are you getting? Yes, please. Hello. Okay, we can. Okay, so let's say with this one.
23. Yeah, 23.
Okay, that's fine. That's good. So let's say this one. Group data like this one. So when it comes to group data, like this is ungroup data, okay, because they are not in classes like this. In a case like this, what do we do? So we are going to find our what? We are going to find our median. Okay, we need to find our median. So when we find our median, what is going to happen is this. Okay, so with our median here, so if the total is what? If the total happens to be odd, that one is straightforward. Okay, so what you do is that so this is my frequency. Okay, I wish I could get. How come I can add another table to the side? Okay, good. Let's see. I think I can split the table. I can split. Okay. All right. Okay, let me see. I think I can split this one. Okay, let me see. There should be a way of me splitting there. Split the cells. Okay, good. Like that. Okay, good. So let's see. Okay, so let's say here is frequency. Okay. Let me split this one as well. Okay, so split, let's say, let me split this one. Split like this. Okay, good. So something like this. So let me just put F for frequency, right? So let me put F for frequency so that it will be easy. Okay, good. Now, so with this one here, so here you can see that something like this here. Okay, good. So when we add everything, okay, can I get sigma F somewhere? Okay, so let's see whether I can put something down here. Okay, let me split this one. Let me put some row. Okay, so let's split the down one into, okay, this down one here. Let me split it into 2 so that I can get it below. Okay, so split it, split the cell into 2. Okay, great. Okay, let's see. Let me split this one into. Oh, okay. Let's split. Let me make it row. Okay. So good. Now I have something here. So let's say now I want to get what? Let me go and steal a symbol online. Sigma. Let me go and get Sigma symbol online. Sigma symbol online. Okay, great. So let me take the Sigma symbol here. So let's say I have my Sigma here. Good. So here, the down here is going to be my Sigma what? Sigma F. Okay. So when I add everything here, so let's take it this way. The Sigma F is what? When you add everything, what are you going to do?
Good morning.
When you add everything,
23.
I'm not watching.
Hey.
Please mute your mind.
Edward.
Okay, so when you get a Sigma F, what are you going to get? When you add everything, what are you getting? Yes, when you add everything, what are you getting?
23. 23.
21.
23 is not 21.
Okay, so you get 23 here like that. Okay, great. Okay, so when you add everything, you're getting 23 here. Okay. Let's see. Okay. Okay, 23. Now I've gotten 20. So this is my Sigma F here. Okay. Good. Sigma F here, 23. Now with this Sigma F, so if it is, we are going to find the median. Now, so in this case, I'm going to, so you see the median is not referring to frequency. The median is referring to the age. So I'm going to find, so now we are going to find median age. This is what we are working towards. We are finding median age. Okay. So with the median age, what am I going to do? So first of all, I'm going to find the middle of this number. Already, you can see that this is already arranged in numerical order. So we want to find the middle of this number. So first of all, so if the number is odd, that one it is straightforward. So Sigma what? So let me carry my Sigma F here. Sigma F divided by what? Divided by 2. So divided by 2. Okay, great. So if it is odd, you don't even suffer. If it is even, you add 1 to it before you divide it. Okay, all right, good. So if it is odd like that, that one straightforward. We don't even suffer at all. So 23 divided by what? Divided by 2. What am I going to get? What will I get, please?
11.5.
11.5. Now you are going to use, now after you've gotten this one, this is not the median. Hello?
So this one cannot be the median, it's the median position rather, right?
Yeah, so please, most of the time, let me land, okay? So that, because sometimes when it is distracted, let me land, and then if you have a question, you ask, so that it doesn't distract your colleagues as well. Okay, good. So what is here, this here is not, this 11.5 here is not the median, okay? But what we are going to use to trace, okay, the median. Okay, so now the question is then one may ask, then what is this? If it's not the median, then what is it? Then what it is, we are going to use to trace the median. If it's not the median, then it is what? It is rather the position of the what? Of the median. That's the median position. Okay, it is the what? It is the position. It is the position of the median. Okay, it is the position of the median. Or let me make life easy. It is the median position. Okay, so for this table form of data, okay, when we divide the median, okay, by 2, if it is odd, we don't even need to add any 1 to it. Okay, but if it is even, we'll add 1 to it, okay, before we'll do the division. So for median like that, okay, like this. So for median position, okay, what we have here is not this 11.5 here. It's not the median, but rather the median position. So it is the median position that we will use, okay, the median position that we use to trace the median word, the median age, okay, to trace the word, the median age. All right, so we are going to use the median position to trace the word, the median age. All right, good. So what is going to happen is now we are going to add from the top. Okay, we're going to add from the top. You see, so 2 plus 3 will give us what? 2 plus 3 will give us. So we'll start adding. So we'll get, so 2 plus 3. Okay, 2 plus 3 is giving 2 plus 3 is what? So 2 plus 5 plus 5 7. Okay, so we can go 2 plus 5, sorry, 5 here will give us what? 7. Okay, great. So we have to continue. Plus 3 will give us what?
10.
Okay, good. Okay, plus. So here, you see that, so plus 3 will give us 10 now. Now, we know that the median value will be what? So the 11.5, okay, position will be here, will be inside 4. Are you with me? Okay, so which means that when we arrange all the numbers, the meaning is that when we arrange the numbers, okay, so here, when we added up to here, we didn't get what? We didn't get 11. So we'll add to, we'll get the 11.5. So here, you see, we are not going to add this one, but we can tell that the what? The median is what? Is 4. Okay, so these values are not many. So let's see something here. So we can do, let me do something crazy here. It's 4 years. Why? Because the next number, the 11 will be here. The 11th number will be 4. And so the 11.5 number will still be in the what? Will still be in the 4. So the median position, which is the 11.5, will land on this one. So this one becomes what? 4 years becomes our median. Now let's see. Let's try to do the old school explanation for this one. Let's see. We have one day, we have 1. We have 2 is 5. 1, 2. Okay, like that. So 5 of them here. Okay, 3. So 3 is what? 3 is what? 3 is 3. 1. Okay, great. 4 is 1. 1, 2, 3, 4, 5, 6, 7, 8. Is it more? 4 here. Okay, 8. All right, good. And then the next one is what? The 5 is what? 4. Okay. 1, 2, 3, 4, 5. Okay, it's 4, right? 4. And the 6 is what? 6 is 1. 6. Okay, good. So if you go the old school way, then I want to find the median. This is already arranged in what? In numerical order. Okay, so I want the what? I want the one in this is 23. So which means that clearly I want the one in what? It is in 23, right? We are in what? 23, okay? So if it's 23 and if I arrange them this way, which means I want the what? The 13th. No, not the 13th position. It's 23, right? The 12th position, right? Good. So let's say when I count here, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay. 7 here. Okay. 8, 9, 10. So this is 10. Let me highlight it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. So let me highlight that one. Let me give you that one green color. Okay, so up to here. Okay, let me give it green color. All right, good. Then I will highlight this one. I will take a 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so okay, good. Like that. Good. Then I want the word. I want the middle number. So here, highlight here. So I'll highlight here again green. Okay, green here, like that. I'll highlight here yellow. And this one becomes my word. So what the one in the middle here, let me highlight it as so let me give you that one red. So this one here becomes our median. So what it means here is that once we add everything, okay, when we arrange all these numbers in numerical order, okay, of magnitude, okay, what is here? This one here is going to be my word. This one here is going to be my median. So we keep adding, and then the class where the median mark will fall, that is it. So here you can see that this group, this particular is the 4. The median one will land on this particular number. Okay, when we arrange all of them in order. Okay, so you keep adding, so you get the word, the middle number. Okay, great. So please, are we clear with this one? Okay. Now let's go to B.
Hello.
Yes, please.
Doc,
Yes.
please, I want to know something. Since you have created a table for the age and the frequency, I think away from the table, you were also summing up the ages and the frequency, right?
Yes.
Yes.
So
Wouldn't it be?
Go ahead.
Wouldn't it be? Wouldn't it be cheaper or clear when we add that one to the table to make a third table?
Oh no, because this is just the frequency here. It's just this one, the one here. So
okay.
Yeah, so in fact, if you are going to do it, you waste time. This one is because the values here, they are not many, they are just 23. So I wanted to illustrate how we had a median to be this, okay? But in reality, you don't need to do this at all, okay? So I wanted to throw more light on it. Why the median? So when we added, so we kept adding. Okay, we kept adding. So when you add as you add, so you get what? So you get value with this one, 8.5. So where the 11.5 will fall. But when we kept adding, the 11.5 actually fell into what? Fell here. Okay, so where it fell, it means that this one becomes our median. Okay. Our median age is what? Is 4. Okay, great. So let's hello, go ahead.
Yes, if I get her question clearly, I think she's asking of fx, so sigma fx.
Yes.
No, not that. No, like cumulative frequency there, not the sigma fx.
No, cumulative frequency. Please don't confuse yourself with cumulative. What is here? This is sigma f. Don't confuse yourself with the two. Please, we will come to it. Let's go step by step. We are doing everything step by step. Okay. Let's stick to what we have here. Okay. Okay, great. Good. Okay.
Hello,
some
doctor.
people are very good with math, some are not. So we don't want to.
Hello.
Yeah, please go ahead.
Please, doctor, how did you come by the old school way of getting the median?
No, so here, the old school way of arranging this one is that one, frequency is 2, right? So 1, 1. So which means that 1, there are 2 of them. So 1, 1. Okay. Are you there?
Yes, please.
2 is 5. 1, 2, 3, 4, 5. 3 is 3. 1, 2, 3. 4 is 8. So I listed 8 of them. 5 is 4. Now I just use this thing to illustrate to you. You don't need to do this. Okay? But because I'm explaining, I use this old school method that all the numbers here, if we are to list all of them, how come we had the 4? So we had 11.5 and we are tracing it. Where 11. So we started adding the frequency this plus that. We still didn't get the 11.5. So it is, so we know that that 11.5 will fall into this particular word age. Okay, so where the age within which it will fall, that age becomes our median age. Okay, and we use, after I've done this, that we've agreed that it is 4 years. Then I went to the old school method of just listing them. It's because there are no many. That is why I listed them to substantiate our claim of 4 years being the median age. Okay, all right, good. So let's do another one. Hello.
Doc.
Yes, please.
Doc, please,
Hello, Doc.
can we also take it this way? That we have our summation F to be 23, which is an odd number. Now, I think I was studying one a statistics book, and it says if it is odd, we should use n plus 1 divided by 2. And then when we have n plus 1, n referring to our summation F. So the summation F, which is summation F, which is 23, represent the n. So we have the n plus 1 over 2, which is 23 plus 1 divided by 2, giving us 24 divided by 2.
Okay.
And the 24 divided by 2, we are going to, it will land on the 12th position.
Yes, please.
And on the 12th position, we counted from the frequency. And then on the 12th position, it is going to land on the 8th.
Okay.
And then from there, we look at it at the age column.
Yes. What you said is right. Okay. What you said is correct. Okay. What you said is correct. You're right. Okay, great. Okay, great.
Can we use that?
No, I get you. You know, what you said is correct. Okay. It's correct. Okay. All right, great. I don't want my people to confuse the two when it comes to the community frequency. That's why I'm sticking to this one. Okay. All right. People,
let's use that or the
hello. Listen, hello. What I'm saying here is that people tend to confuse the two.
Yes.
Okay, right? Because we'll do the cumulative frequency. Hello.
Yeah, but what my brother said, but Doc said the summation F plus 1 is for the, that is for the median, is for the even. But my guy is applying it for the odd.
Yes.
It's n plus 1 divided by 2.
It's supposed to be for the odd.
Hello?
Please don't confuse us.
Hello?
Yes.
Yeah, what our brother is saying is when the numbers given to you is even number and you have to select two numbers and divide it by what? 2. But with this one, when the total is odd, that means the n is the total, which is what? Let's assume it's 23. So 23 plus 1 divided by what? 2. To get an even number. Then that even number.
So the summation plus 1 divided by 2 is for odd, not for even.
Yes. In the sense that when the total is odd, but the even is when the numbers are 8, and maybe you have to select two numbers among, which is the middle two numbers. Please, have you gotten it?
Come again.
Yeah, I said the odd. When the total, like the sigma F, is odd, that is when you use the formula n plus 1, and the n is the total. Then you divide it by what? 2 to get an even number. Then that even number will show you to the table in which we are referring to. But when
the summation was 23,
yeah,
was
when
odd
the
number, 12 used 2 divided by 2 without adding one.
What?
Yes.
Please, hello. Please pay attention here. Please pay attention. Hello, are you with me? Okay. Hello. Are you there?
We are listening.
Okay, now listen to what I'm saying. Okay, good. Listen. What he's saying is right, okay? But what I'm saying here is that we'll be doing, because I will be doing the cumulative frequency one as well here right now, okay? And usually people tend to, in cumulative frequency one, you use this one straightforward, okay? All right. So whether you add a 1 or okay, or even you don't add it, okay, you will still even arrive at the same point, okay? But I don't want people to confuse both the cumulative frequency method that we are going to do as well as this one. That's why I've actually stick to this one. Did you understand what I'm saying here? Hello? Okay, great. So what I'm saying here is that, okay, we don't want a situation that people will get confused when it comes to the what, the cumulative frequency method. Okay, because we'll do right after this one, we'll do the next one with the cumulative frequency method. So what our brother is saying, it's not wrong. Okay, it's not wrong at all. All right, good. So when it is even, okay, when it is what? When it is even, our brother is saying that when it is even, you do what? You add, you said that when it is odd, that you add a 1. Is that what you said?
Yes, Doc. Yes, Doc. N plus
When
1
it
divided
is,
by 2.
when n is what? Even. When it is odd.
Doc, when it is odd, n is the summation f.
That's when you add a 1. No,
That you add the 1,
that's not
then
true.
you divide it by 2.
No,
Sir,
you add a
sir.
1 when it is even, rather.
Hello.
Hello, you add a
Sir,
1
sir.
when it is even. What I'm doing here is correct. You
Hello,
add
sir.
a 1. You see what we have here is odd, right? It's 23. Okay. Listen.
Hello, sir.
Hello.
Please
Hello.
allow Doc to
I want
present.
to want to clarify something.
Okay, go
Is
ahead.
that what our brother is saying is totally right, but it is different. That one is
It's when they give us a lesson one, right?
a
This
lesson one without
this
a
one.
table.
It's not for the table one.
Yes, yes. When they
When
list
they
the
give us
numbers,
this one.
that one you're not going to use this formula. But when it's given like a table, that is where you will use the one that you are showing us right now.
Please, do you understand what I'm saying here? So don't confuse with this one. Okay?
Yes.
Don't confuse with this one. So here with the table, when it is okay, so let me put it this way. So you with the table, when the word when the sigma, okay, when the sigma f is what is odd. When the sigma f, okay, please don't confuse yourself here, please. Okay, when the sigma f, okay, is odd, like the one we have here, okay, are you with me? When the sigma is odd, you don't add the 1. You add the 1 when it is even. Okay, so here, so what I'm doing here is correct. Okay, all right, okay. When it is odd, okay, when the sigma f is odd, like that, okay, odd number, like that, okay, okay, don't, let me write in capital letters, okay, don't add the one, okay, but when it is even, then you do what? You add the 1. Please, are you with me here? Hello? Please, do you understand?
Please,
Yes,
it is
sir.
don't add,
Hello,
not
hello,
don't
sir.
or.
Hello?
Hello, sir.
Yes, go ahead.
If it is even and you add plus 1, if you divide it by 2, you are going to get the answer. You have 0.5 to eat.
Yes, it won't change anything. It doesn't change it. That's position. Listen, let me show you something here. Let me show you something here. You are confusing to look at something here. Look at this here. Have you seen what we have here? Have you seen what we have here? It's even, right?
15.
Please make sure I land before. Listen to understand. Don't listen to ask questions. Okay? You ask questions when you don't understand. Listen so that you will be able to learn. If not, you also confuse other people. Okay, listen to understand, and then you will reply. When your intention is to reply, you will not listen, and then eventually, okay, now look at what is here. Look at what I have here. If I come to this lesson here, and they ask me, what is the median? Now, we can see that this is even. So the median is here. The median is here, right? Now, if I count 1, 2, 3, 4, 5, okay? If it 1, 2, 3, 4, 5, 6, okay? Now, if you take 3 here, and 3 here, okay, like that. Like that. You see, we are not getting any median. The middle number in terms of position, the middle number will be in this position here. Will be here. Okay? Will be here. The middle number will be here. So what is that middle number? So that middle number will be 5, but that number is not there. Okay? So based on the number we have here, the middle number, if we are to use in terms of position, the position, if you are used by position, the position here will be what? 3.5 position. Are you with me? So 3.5, fifth position. All right, which is here like that. And the 3.5 position here is going to be 5 based on our calculation. Do you understand that? I don't want us to do so much on because this is a little bit tight on the trivia side, okay? Please, do you understand what I'm saying here? Hello, are you with me?
Yeah, we understand.
Look at this number.
Yes.
In terms of position,
Yes,
in terms of position, we arrange this number in order. In terms of position, the number should be here. And this position will more or less, we'll call it like 3.5, okay, 3.5 position, which is here, okay, which will be here, okay, and that will give us 5, okay, good, okay. Now, when we come to the table and you are dealing with odd numbers, okay, when you add and then your sigma F is odd number, you don't what? You don't add what? You don't add 1. Okay, but if it is what? Even number, you add 1 before you divide by 2, and then you go and trace it. Okay, so let's take it this way. Please, do you understand what I'm saying here? Okay, this is only when you have it in table form. Okay, so don't confuse yourself with the listing. The listing is like this one is like this. Okay, this is listing. That one is like that. The position will be here. Okay, this listing. But when you come to the table form with large number of values. So for the table form, what you do is that if it is odd, you just divide the sigma F by 2. Straightforward. All right. Okay. And then when it is
Hello, Doc.
Yes, please.
Please
go ahead.
Why should you add 1 at all? Why? Because if you decide not to add 1, won't you get the answer?
If you add the 1, the reason we add the 1 is that you see, in the case like this, if you look at this one, okay, if you look at this, let's see, look at this one here. The order 1, 2, 3, 4, 5, 6, 7. Okay, there are 7. When we add the 1, it means that the 1, so the sigma F is 7. So when we add the 1, it will tell us that the fourth value, that's what it means. Are you with me? So here, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So because there are 9, it means that when we add the 1, we get 10. 10 divided by 2, 5. So it means the fifth value. And what is the fifth value? It's 8 here. Have you seen it? So if you don't add the 1, we won't get it. Okay, so it tells us the fifth value. Then we use it to trace our fifth value, which is 8. Okay, so the median position is 8 here. Okay, and you can see 4 on the side, 4 on the side, and this is the middle number. Okay, great. All right. Okay, great. All right. So please be careful here so that you don't get confused. Because okay. All right. Great. So for odd numbers, okay, what you will do is that you don't add the 1, okay, but for even number you add the 1, okay. So this is the correct thing, okay. All right, great. Okay, great. For the table, okay, great. So this is that. Now let's see another example. Let's see if I give you another example like this. Okay, let me duplicate my slide here. Okay, so let's see, this one goes here. So let me duplicate my slide here. Let's say I duplicate this slide. Now if I duplicate this slide, let's say if I get something like this. Let's say if I get something like, here is 3, here is 6, here is 5. Okay, let me make it even 7. 7. Here is 8. 7 plus this. Okay. Okay, so 8. Okay, and then Here is here is okay, so let me keep my 8 here. So 8. Okay, so when you add everything, what am I going to get here? Okay, nice. What am I going to get? What am I getting? 30, right?
30.
Good.
The eight is
Good. Now, this one, we are finding the median. 90 is what? The number is what? Even. Even number. The number is what? Even. Okay, great. So with even number, now look at what you will see here. Okay, with even number here, let's see what you are going to get. Okay, all right, great. Okay, so with even number here like that. Okay, so let me take this one out here like this. Okay, all right. So let's see something. So in this case, with even number, what are we going to do? Our position, our median position, we need to find our what? Median position. Okay, median position. So median position with even, what we will do? We will do sigma f plus what? Plus 1. Sigma f plus 1. Okay, all divided by 2. So let me make it this way. Sigma f plus 1 all divided by 2. So in that case, what are we going to get? Now let's see. So our sigma f here is now where? It's now 30. You will see something. You will see something very soon. 30. Good. Now look at the 30 here. Now, so we'll get what? 30 plus what? Plus 1. Okay. 30 plus 1 here. Okay. All right. All divided by what? All divided by 2. Okay. And that will give us what? That will give us what?
15.31. 15.5.
Which will give us 15.5. All right. Now look at it. We are coming to trace it. Okay. We are coming to trace. Okay. So this is our median position. So this one here, let's call it, let me make it 15.5. Okay, so that's the median position. So we are going to track that position and see where it's going to land. 2 plus 6, okay, plus 7. What are you going to get now? What's the answer now?
15.
It's 15.
15.
Good. Now we are getting 15 here. 15. All right, good. Now, the next one is what? The next one, which means that the next one, the value we want is 15.5. Okay, it's 15.5. Okay. Now, do you know the meaning? Do you know the meaning? Here we have 15. The next value, if we add the fourth one, okay, so do you know what the meaning of this one? What it means here is that when we arrange all the numbers, okay, when we arrange all the numbers the old school way, okay, let me show you something here.
Hello, is it my end or is a general problem? The network. Doc, I can't hear your presentation. I can't see the presentation any longer.
It's a general problem.
General problem.
Yes, muted himself.
Yeah, I can't hear anything.
Yeah, it's not your
Okay,
problem.
thank you very much.
It's not for me. Okay.
Hello, are you there? Hello, my people.
Yes,
Yes, we are there.
yes, dog.
Hey, but I just come to this side. Then it means there is a network. I didn't even touch it. I'm not. I don't even come to that. I'm only using my this thing. Okay. Oh, sorry about that. Okay. Okay. So what we are saying here is that if you look on my screen here, when we add everything, we had 30. Okay. And because the sigma f is even number, we want to trace the median position. So the median position. Okay. So the median position. So let's say median position. Okay, that's MP. Median position is equal to what? Okay, is equal to, that is what? It's equal to sigma f plus 1 all divided by 2, which is giving us the what? 30 plus 1, which is giving us 31 divided by 2. And that gives us what? 15.5 position. Okay, now let's start the addition. This plus this plus this. We had what? 15. Is that not it? This is what we had here. Okay, now you can see that my 15th value is 3, but my 16th value is 4. Do you people agree to what I just said? Hello?
Yes, sir.
Yes, please. Yes, please.
So you can see that when I arrange all the numbers in order, like this way. So let's see. I will try the old school here. So 6. 1, 2, 3, 4, 5, 6. Okay, so let me add 1. The other one, 3 is 7. Okay, you don't need to do this, but I just want you to see something. That's why 1, 2, 3, 4, 5, 6, 7. Okay, good. And then this thing is still 8, and then 6 is 3. Okay, so let me drag this in a little bit. Okay, okay, great. So let me push this one here. Okay, great. So I get more space. Okay. Okay, so if I 6 here, okay, great. So let's see 6 here. 5 is what? 4. So 6 is 3. 3. Okay, great. Now look at something here. So when we added the 1, the reason we add the 1 is clear here. So here you see, I deliberately chose these figures. Okay. Now, okay, you can see that after we added the 1, we want what? We want 15.5 position. This is the position we want to find our median. So we use the frequency. When we add the frequency, this is the position we want. After we added, we realize that from here to here is 15. When we added this, all this to here, 15. Okay, we are having 15 here. So the 16th value will be 4. Okay, but what we want, our position we want is 15.5. So what are we going to do? Now look at the old school thing that we did. 1 is 2 here. Now let's see something here. If we use the old school, okay, let me kill this one here. Okay, let me kill this one here. Okay, good. Like that. So let's see something here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 14, 15. See that the 15th position is here. This is the 15th position. The 15th position is what? It's landing on 3. Okay, from this old school thing. Okay, great. But what we want is what? Is 15.5. Okay, and if you go down here, from here going to be 15. Like that. But what we want should be here. Please, do you understand what I'm saying? Are you there?
Yes, sir.
Good. So
Yes,
in this case, have you seen that we want 15.5 15.5 position. So with this 15.5 position, what are we going to do? We are going to add 3 and what? 4. Because these two numbers, okay, we'll add these 3 and 4 together, okay, because this is the position we want. We want the value here, not this, not that, okay. So in this case, what are we going to do? Our 15 position will be 3 plus 4, okay, which is going to give us what? 7 divided by 2, and that will give us what? 3.5. So this 3.5, okay, becomes our median. Do you understand what I've done on the board? Hello? Are you with me? Hello?
Yes, please.
Yes, sir. Yes, sir. Please. Yes, Doc. We are with you.
Obviously, good. Now I'm going to duplicate this slide again and then look at something here. Now let me change, still on this one. Now still on this. Now let me change here to be 2. Let me change here to be 2. Okay. Let me change here to be 2. Okay. And then find the median for me. Find the median now for me. Yes. Now here is going to be what? I've taken that one. Find the median for me. Yes. Where is the median going to be? What's the median? Yes. Yes. What is the median? Yes. Any headache? Okay, so here now the total is now 20. Now, so I've changed something here. I've changed it. Now the total is no longer 30. It is 28 now. And I've asked you to find the median. I've changed it. Okay, so let me number them. Let me give this one maybe 1. Okay, let me give this one 2. And let me give this one 3. Okay, good. Now this one is 20, and I'm asking you to find the median. What is the median here?
So it's 3.
It's 3.
Please, the median is 3.
The median is 3. Okay, great.
Yes.
Now let's see something here. When we divide this by, so now we have what? We'll get 24. Okay, so it's 28, right? So 28, okay, plus.
28.
So our sigma F now.
1.
So our sigma F. Our sigma F is equal to 28. Now we are going to find our median position. So 28 plus 1 divided by 2. Divided by 2, because it is okay, like divided by 2. So that will give us what? That will give us divided by, that will give us 14.5. Great. So this one is the median position. So this is the median position. Okay, position. So this is what we are going to use it to trace our median. Okay, median position. Now, so let's see. So we'll start, we'll add. Okay, 2 plus what? 6. Okay, it's what? It's 8. It's what? 8. Okay, all right. 8. Good. And then so 8. Okay, good. Now when we add the next one will take us to 15. But you can see that this is 14.4. You can see the list here. You can see the list here that when even though this is 14.5, and when we add the next one, will give us what? 15. You can see clearly that when we list the 3, all the 3s, the middle number will be inside of it, will be what? One of the 3s. Please, do you understand what I'm saying here? Okay. If you look here, which part is confusing you? Which part is confusing you?
Say the median. the median position.
Yep.
How did you get the 2 plus the 6?
The 2 plus. So we are adding from the top here, the frequency. We are adding till we get something close to this.
Okay, sir.
2 plus 6. So we add from the top. 2 plus this plus that. So even though when we add this one, it will exceed the 14.5. But we can see clearly that that value will be here. Will be one of the trays here. Are you with me? Okay. All right. So let's say, I don't have approximation symbol. Let's say plus 7. Let me put it in quotes. In quotes here. Okay. 7 in quotes. Okay. So like that. In quotes here, like that. So we will not add the 7. Okay. But we will know that when we add it, we will know that the next number is what? The 14.5, okay, will be inside of the trace, okay? Because when we add this one, we get 15. So that 14.5 will be inside the what? The trace, okay? Do you understand what I'm saying here? Okay, so if you go the old school, way, okay, so look at the old school way, like the one I have here, okay? All right, good. So here, 3.0, okay, good. Now, when you go the old school way, now we've arranged all of them here. Now, we have one of them, 1 is 2, 2 is what? 6, okay? 2 is 6 here, and then 3 is what? 7, and stuff like that. Now, let's see, we want to find the median number, okay? And we say that the median number will be in what? 14.5 what? Position. So let me count 14. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So, all right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is the 14th. Okay, let me highlight this one. Great. Now the next 14. Okay, oh, this one is not part. The next 14 is this yellow. From here to here is another 14, like that. Okay, another 14. Okay, like this one. Okay, good. So let me highlight this one with different color. Okay, let's say blue like this one. Now, so the middle is here. The 14.5, okay, the 14.5 is going to be what? Is going to be within this number. Okay, so that will be here. That number, this is the first 14. The 15th is what? Is 3 here. Now, when you add 3 plus 3 divided by 2, okay, you will still get a 3. Okay, have you seen what I've done here? You see, if you add the whole of this, we need 14.5. So if I'm using this old school method to explain what is here. When we add when we count the numbers in order, the count is this. So let's count the other way here. So this is the first 14. This is the next, that's 14. So the middle number, okay, where is our middle number going to be? Okay, all right. So first 14 is this. I think it's this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, great. So you can see that this one is the first 4. The 14 is here. So these two. Okay, these two will be having in the middle of this one here. Okay, the 14th one lands on this. Okay, and then this is the word. This is the 15th. The 15th will land on this one. Okay, but this is what we want. We want, when we add a 0.5, we want the number here. Okay, we want the number here. And so if you want the number here, when we add this and that, what are we going to get? Because we want 14.5. And this is our 14th value. Okay, all right. This is our 14th value. Okay, and this is our 15th value. So this the middle, the number will be in this middle. So for the number to be in this middle here, what are we going to do? You add this and that. And when you add 3 plus 3, you get what? You get 6. 6 divided by 2, you get what? You get 3. So the median is 3. The median age is what? The median age is 3 years. Any confusion so far? Okay. In exam, you don't need to do this old school thing. I'm using this old school to substantiate what I'm saying here. So what you do is that after you've added the 1 to this one, if it is even, you add 1, and then you divide it by 2. Then you start counting, you start adding from the top till you get a number close to this one. So where that value will land, where it lands, then that is where the median is what is located. If it lands in between 2 groups, like this one here, you see in this case, it's finished on 15th was here, but 16th is here, but we want 15.5. So in this case, which means that the value is between what? Is between 4.1. Is between 4 and 5. Okay, and in that case, what do we do? Okay, in that case, which means that no, it's between 4 and what? 3. The previous one, when we did it, it was between what? 4 and 3. So if it's between 4 and 3, we'll add 4 and 3 and divide it by 2. Okay, that is all. Any headache so far? Please, any headache so far? Hello? Any headache so far? No? Is everybody okay with this one? Okay, let me give you one. I want you know what, because you must understand this one. Okay, let me give you one. Okay, I'm going to give you one. Okay, so let me duplicate my slide here and give you one and see. In fact, I'm even going to give you 2, and let's see how. Okay, so let's say okay, so let's say if I give you something like this. Okay, let's say if I give you here, 4, okay, and then let's say here is 5. When you add everything, this is what are you going to get? This plus this, 8, okay, 12, okay, 15, yeah.
It will be 23.
23. Okay, 23. So let's make this one
8,
2,
12.
okay, and 1. What is that? What's the total?
17, 20.
20. Okay.
18.
Find it.
18.
It's 18. Total is 18. Okay, fine.
18.
Find it.
18.
18.
18 here. Okay, great. So this is your question A. Okay, then let me copy this one here. So find the median for this one. Oh no. Let me see. Find the median for that one. Let's see. I can copy this one. And then let me put this one here. And then let me make this one. And then this side is B. So this is A. Okay, good. So find the median for this one. Okay, we need to master them because they are coming in the exam. No two ways about that. Okay, they are coming in the exam, so let's master all of them quickly, and then that will be fine. Okay, so you're finding the median for A, and then you're finding the median for, so let's say find the median for this one. Let's say this one is I. Okay, and let's say this one is II. Are we done? Are we done? Are we done? Hello. So you're finding you're finding the median for this one, and you're finding the median for this one.
Hello.
Yeah.
The I is 3, and then the II is 3.5.
Let's see. Okay, let's see. Please, are folks getting the same answer? Let's see the I.
Yes,
Okay, good. So now let's do
yes, sir.
Okay, so let's
Sir.
hey, hello.
Sir, the I is 3 and then II is 4.
I is 4. Okay, so let's work it together and let's see. So let's see. Here is what? Here is total is what? 18. Okay. So when 18, they are always. So this is what clearly what is here is clearly what? Clearly even, right? Okay, let me go back here. Oh, where is it? Okay, so let me get this one here. Oh, well. Okay, well, let me write it inside it like that. Okay, good. So let's see. Now you can see clearly that. So our sigma, I'm out to find my word median position. So median position is equal to what? It's equal to sigma what? Sigma F. Sigma F.
Summation F. Sigma summation F.
Okay, sigma F divided by 2. Okay. Like that. And that will give you what? 18 over 2, which will give you 9. All right, good. So now it is 9. So I'm going to look for 9th position to trace my what? To trace my median.
No,
Yep.
please.
So
No, it's not.
You said you are
Plus 1.
Plus 1.
19.
This is what? This is 19.
Plus 1.
Divided by
That's supposed
This is 19.
When it is
Is
even,
it
we add 1 to it.
An odd number plus 1.
Divided by 2, but you wrote 18
Oh,
divided by 2.
oh, so 19 here.
Yes, sir.
Yes, please.
90 plus 1 will give you 9 plus 1. It should be 18. Okay, like that.
So 18
1.
19
So
divided by
19 divided by 2.
9.5.
19 divided by 2, and that gives me what? 9.5.
9.5.
9.5.
Okay, great.
The position.
That gives me 9.5. Okay, great. Now that so this 9.5, so I'm going to use it to trace. So that I'll start adding. You add a word. You start the addition from the word. So you come to trace your mean. So you start 2 plus 6
plus
okay
4
plus. So here you can see that 8. All right. So here there are 4 here. So clearly you can see that the median, the median number will be inside 3 here. Okay, because you need to add how many more? You need to get 2 point where you need to get 1.5 more, and there are 4 here. So which means that the median will be one of the 3s here. Okay, so from this tracing, from this, okay, so from this tracing, okay, from this tracing, you can say that what the median is equal to what? It's equal to 3 years. All right, great. Okay, now let's come to this side.
Okay.
Let's come to this side here. Okay, if I come here, let me carry. Okay. If I come to this side here, okay. If I come to this side, you can see that, you can see my word, my total is what? What's my total here? 24, right? 24.
24.
So 24. So 24 here. So 24. 1. So that I'll get 25. 25. Okay. Divided by what? Divided by 2. Okay, that will give me 11.5. Wait, 12.5. 12.5.
12.5. Yes.
Okay, great. Now, so let me start adding. So when I add, I will get what? I will get 1 plus this. What am I going to get? 1 plus
2 plus 6.
Okay, great. So I will start adding from the top. Okay, so I want to get 12.5. So which means that my median position MP is what? Is equal to, I want 12.5 position. So I'll start my adding. Okay, I'll start my summation, and I'll get 2 plus what? 6 plus 4. I'll get what? That's 8 plus 4. Okay, so I'll get what? 12.
Yes,
Okay,
12.
good. Now you see that 12 has landed on 3 like that. This 12 has landed on 3 like this. Okay, it has landed on 3. Okay, like that. Okay, this 12 has landed on 3. And put this one. Okay, it's landed on 3. Good. Now, but you see, we've not gotten our 12.5 yet. So
Yes.
which means that the 12th. So from here, what it means here is that the 12th value from the list is what? Is 3. And the 13th value is what? Is 4.
4.
Because the 13th one will enter here. But what do we want? We want value at what? At 12.5. So which means that 12.5 will be between here. Okay, so it means that 12.5 value, you have to add what? You have to add the 12th value and the 13th value. Okay, and that 12th value is 3, and the 13th value is what? Is 4. And then so that will give us what? 7. And then after this and that divided by what? 2. And so that will give us what? 7 over 2, which will give us what? 3.5. 3.5. Yes. Please, do you understand what you've done?
Doc.
No. Yes, please.
Hello, Doc.
The previous table.
Mm-hmm.
The previous table, you said they force our 9.5 position is on 4. It's on 4.
No, it will be inside. This 4 is frequency. Listen, when you say median, the median is not referring to this number. So it's referring to what is here.
No, I'm talking about the position.
Go ahead.
The 9.5 position.
Mm-hmm.
It's landed on.
Go ahead.
It's landed on
3.
On the 3.
Yes.
And you said the trees are 4. So it will be in between 1 tree and another tree because the trees are 4.
Yes.
But here, the next table, the one we are working with.
So good. Please, if I'm not interrupting, 3 plus 3 divided by 2 will give you what?
It will give us 2.
Hey, 3 plus 3 is what?
It's 6.
It will give us 3.
Divided by 2.
3 plus 3
So
is 6.
it's yes, divided by 2. So it is, you are listening.
It's 3.
It's like that. So it is straightforward. Are we listening? Because when we add it, it will still be the same value. So when we add 3 plus 3 divided by 2, you will still get the same value. So because you still get the same value, there's no need for us to write it. But in this particular case, when we jump into the next one, okay, 3 plus what? 3 plus 3 divided by what? 3 plus the next one here. When it is jumping to the next one, it is what? 3 plus 4. 3 plus 4 will jump into the next one. Okay, because we know.
Please mute your mic for us.
Doctor, I'm saying that the tree on the edge, and then the 4 on the frequency. If we are applying the same rule that we applied in the first table, then it's supposed to be 3 plus 3 because the trees are also 4 here instead of 3 plus 4, which will give us 7.
I'm not getting the question you are asking.
I am saying that with the first table, we landed on our 9.5 position on 3.
Okay.
And then we added 3 plus 3 and divided it by 2.
Yes.
Right?
And then we get 3.
You said the trees are 4. So we'll land on 3 in between 2 trees because the trees are 4. But here the trees are 4, but we are adding 3 to 4.
No, when we also arrange them, we will land in between 3 and 4 in this case. When we do this, when we do this one, okay, when we do this, oh no. Okay, let's take it this way. So how many words? So we have 1 1. 1 1 is here. 2 is what? 6, right? 1 2 3 4 5 6. 3 is what? 4. 1 1 2 3 4. Okay. 4 is what? Okay, so let's say. Okay, so let's see. 1. Okay. All right. Good. So we have the next one as well. We have the next one. 4 is what? 6. 1 2 3 4. 2 here and there. Okay, so 1. Okay, the next one is what? 5 is 2. 6 is what? 6 is 4. 6, 6. All right, good. So let's see for this one. So if this is, you don't need to do this, but I have to go to this mark so that you understand it. What I'm saying here, look at that. So let's say if you count, we want which position? We want what? We want which position? We want the 12.5 word position. Okay, 12.5 position. We want the 12.5 position. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that not it? Please, are you paying attention?
Yes,
Please,
please.
are you paying attention? Great. So
Yes,
have you
sir.
seen where the 12 landed? Hello, have you seen where the 12 landed? Hello, can you see where the 12 landed?
Please. Yes.
Hello, good. So the 12 is here. The 12 landed here. Okay, the 12 landed here, like that. And let's say, let's count the next 12. The next 12 is here, like this. Now, where should the median value be? The median value should be where this color is. Is that not it? Adam, the median value is 12.5 position. So the 12.5 position will be in between this. Will be in between this and this. Have you seen it? Are you there? The 12 landed exactly on 3. Okay? And here, but what we want is the word is 12.5. And where is the 12.5 value? The 12.5 value is here. It's in between 4 and 3. So if it is in between 4 and 3, what do? You add 4 and 3 and you divide it by 2. Please, you understand it now?
No, doctor.
Please, this one, I'm sorry, I have to continue. So maybe after class, please. I don't know what to say again. From what I've done here, if you don't understand, I don't know what to say again. What is difficult? Tell me, which part is confusing you?
Without doing the old school method. How am I going to identify my?
Listen, please pay attention to me here. You have to listen to understand. I'm using this old school to substantiate what is there. What I'm saying here is that here, the 9th value, we are here. Look at this side. When we are this plus this, okay, what am I doing? Is going to get 8. So I want what? I want 9th. Okay, 9.5. Okay, so the 9.5, look at what I'm doing here. The 9.5, okay, will be, so the 9th one will be 3. Okay, the 8 landed on 2. Is that not it? Hello? Yes. The 8 landed on 2. Is that not it? From on this table. So the 9 will be 3, right?
Yes.
The 10 will be 3, right?
Yes, doctor.
The 11 will be 3, right?
Yes, doctor.
The 12 will be 3. Okay? Is that not it?
Yes, please.
And then the 13th will be so here the 13th will be 4 from here, right?
Okay. Yes.
Good. So here, if you land on the 9th, so let's see that. So here is the 8th. The 9th is this. This is the 9th value. The 9th value is this. This is the 9th. This is the 9th. The next one here is the word, is the 10th. The next one here is the word, is the next one here.
Nimatu, please check your place.
That's not me. Oh, my thing is muted, please.
I think it's Nash.
Okay, so like that. So that will give me, so this is the 13th one. So the 13th one is the 4th, right? Okay, so you want 9.5. This is 9. And this is 10. So the 9.5 is here, right? Nimatu, are you there? Hello?
Yes, please.
Hello, sir.
Where would the 9.5 be? 9.5 would be where this here, this space. Is that not it?
Yes, please.
So what will you do to get your answer? You write 3 plus 3 divided by 2. Is that not it?
Yes, doctor.
Yes. So once it is 3 plus 3 divided by 2, there's no need to write 3 plus 3 divided by 2 because it is still within 3. So that's what I said here. Once you get here, it is 3 plus 3. The number you are looking for is here. The position is here. So when you add 3 plus 3, it will give you 6 divided by 2. You will still get 3. So there's no need for you to do it. There's no need for you to write 3 plus 3 that, okay, when you get here, see this one, when we go to here, the 8th value is where? The 8th value is 2. The 9th value, so here, 3 of them, there are 4 of them. So the 9th will be 3, the 10th will be 3, the 11th will be 3, and the 12th will be 3. There are 4 of them. The 13th will be 4. So I want 9.5. Okay, so this is this one. So it is between here and here. So you add this and this divided by 2. 3 plus 2 divided by 2, we give it 3. So when you know that it is within that particular group, there is no need for you to write 3 plus 3 divided by 2. But here, the numbers are different. The 12 landed on 3 here. And then the next number is 13, but we want 12.5. Please, do you understand it now?
Yes.
Good. Thank you. All right. Okay, great. Okay, so this is that. Okay, great. Now,
thank you, doctor. Thank you very much.
Let me give you this. Let me give you this.
My sister are from the same center, and Doc is interchanging our names. Nash is different from Nimatu.
No problem, but I'm happy you've understood it. All right, so let's see something here. So let's say if I give you something like that. Now, let's say for group data, okay, let's say median for group data. Okay, so in this case, let's say we have a group. So let me take the first thing that we did previously. Let me take my group here. Okay, let me take this table here, and then bring it here. Okay, right. Okay, so something like this. And then you are being asked to find, so let's say there's 9, okay, like that. Okay, good. So in this case, you will be asked to find when it is grouped like that. Okay, when it is grouped like this, okay, what can we do? What we can do is to, and then we'll be asked the word here, we'll be asked of the median class. Okay, something like this. You'll be asked of the median class. Okay, median class. All right, good. So median class like that. So when it is, so this one is for what? For group data. Okay, so median class, okay, like that. So for median class, so here still we'll add everything as usual. Okay, when we add everything here, we are going to get what? We are going to get okay, so let's take it this way that let's say here is, let me say here is 7. Let's say here is 7. Okay, like that. And then they ask us to find the median class. Please, what class is it gonna be? Yes, what will be the answer?
Doc, please, it will be between 10 and 19.
Okay, 10 and let's see. So this one we had a word. Let's take it this way that for group data, let's see. So we have 9 here. This plus will give us what? What's the total here? Hello, what is the total?
20.
It's 20.
20.
Hello?
20.
Yes.
It's like, what is
Hello.
going on? What is going on? I can't hear Doc's voice. Is it my end or it's a general problem?
I think it's your end.
It's your end.
Your end, your end.
It's your
Please check your data. Check your data.
Data.
All right. So we have a word. So in this case, like that, okay, let's take it. So when we add everything, we have 20. So 20 means that our sigma f, okay, let me go and pick sigma f here. So our sigma f, okay, let me take the whole of this. Okay, so we need to get our median position. Okay, so first of all, we need to get our median position. So here, the total here is what? Is 20. So 20, because this is what? So 20 plus 1 will give us what? So it will give us, so for median position, will give us what? 21 divided by 2, and that will give us what? 11, that will give us 10.5. 10.5. Okay, great. Now let's see. I'm going to add. Okay, so they asked me to find my word, my median class. Okay, great. And please, what's the answer? What's the median class? The median class will be what?
10 to 19.
10 to 19.
10 to 19. 10 to 19.
You can see that when you add, when you add from the top, okay, so you add 4 plus what? So this one, so 4 plus, okay, so you can see here. Now, even though when we add it to exceed, but clearly you can see that 10.5 will be within the side, because when we add this one will be what? 10.5, and when we add, we are going to get 11. So that 10.5 will be within here, okay, within this field. So from then you see that it was what? Here is going to, so median class is what? Is 10 to 10 to 90. Where from 10 to 11?
No, the person is talking to you.
Oh, okay. So the median class is what? Is 10 to 90. Okay, all right, great. Now, I think looking at our time and the way I'm hungry, what I will do is I'll quickly run through the cumulative frequency one, and then after that we can call it a day. We'll do the mean later. Okay, please. Okay, so let's see the median for cumulative. Okay, cumulative word. Okay, cumulative frequency. Okay, so median for cumulative frequency. Okay, great. So now let's see something here. Okay, great. So for cumulative frequency, we don't add 1. Okay, so let's see a table for cumulative frequency. Now let me bring this table here. Okay, let me bring this table so that let me. Okay, do you know what? Let me duplicate this one rather. Okay, let me duplicate this. Okay, and then make it median for cumulative word frequency. Okay, median for cumulative frequency. Cumulative frequency. Cumulative should be double in, right? Frequency.
It's one.
Yeah, cumulative frequency. Okay, frequency. All right, so let's see something here. So now we have our cumulative frequency here. So when we get a table for cumulative frequency, okay, so for cumulative frequency, what do we need? For cumulative frequency table, so we'll get a table before we draw the curve. Okay, so let's see something here. All right, here. So median for cumulative, so let's see the table is here. Now in this table, what we need is you need something, because so here when you are constructing, let me take we don't need a class midpoint. We don't need a class midpoint for this. So we will call something mark less than. Okay, that's what we use here. Okay, great. So I'm giving you, okay, so let's see this one here. Okay, let me this is class boundary, so let me make it CB. Okay, CB here. All right, and then let's say this is F. Okay, so what is going to happen is that we need what? We need mark less than, and then let me put this mark less than here, and let me put here's cumulative frequency. So what is going to happen is this. So here, mark less than is you only write the upper class boundary, 9.5. Okay, the next one is what? 19.5. The next one is what? Is 29.5. So mark less than, you only write the upper class boundaries. Okay. And the next one is what? So in this case here, let's see, let me put this one here like that. Here is what? 39.5. Okay. So, and then let's see the cumulative frequency. So the cumulative frequency, what you do is that you add, so you add everything in like in additive manner. Okay, so here is 4, and then when you get here, you add this 7 to this 4. Okay, so when I add this 7 to this 4, what am I going to get?
So the last one, 39.5, you've written 9.5.
So we will get what? We add this to this. Okay, and then we get what? We get 7 plus 4 is 11.
11.
Okay. 11. And then 6 plus 11, 17. 17 plus 3, 20.
20.
Please, who doesn't understand this one?
I don't understand.
Which part that you don't understand? Which part?
The mark less than. And
the mark less than, you only write the upper class boundary. The upper class boundary, that's all. So here, we wrote just this one. You wrote this, that, you wrote that, you wrote that. That's all that you do. So that's upper class boundary. So that's what we'll be using for the plotting. Okay, are you with me?
Okay, sir.
So this is that. And then the cumulative frequency. So the first one, you write your first one here. The second one, you add this to the first one. Then you add, okay, so that's what you call cumulative. So that's additive. Okay, you keep adding. So this one is 4. We added a 7 to 4, 11. We added 6 to 11. We had 7. We added 3 to 11, 17. Okay, we had this 6 to 11. We had 17. We had 3 to 17. We had 20. Okay, like that. So that's so always your last value there will be equal to the what? The sigma f. Okay, the summation of what? Of the whole frequency. So always your last value here will be equal to your sigma f. Okay, so when you finish, you are going to do the plotting. Okay, what you do is, so let's say, let me draw here. Okay, so let me do this in draw. So let me draw here like this. So I will do this. Okay, so I will draw my graph this way, like that. And then this side is my cumulative frequency. So CF, let me put CF here, cumulative frequency. Looking at my interval, so let me put here maybe 4, 8. Okay, so 4, 8, 4 here. Okay, that's from this side. The line put here is 12. And then here is what? Here is 16. And this is what? 20. Okay, good. So with this one, then you are going, so then what you write here is that you write mark less than here. Mark less than here. So here, I'll tell here, this is my 19.5. Okay, let's see, 19.9.5 here is here. The next one is where? The next one is 11. And the next one is 19.5.
19.5.
The next one is where? 29.5.
And 39.5.
And then the last one is 39.5. So you see, you can see that the values are starting from 0. So if the values are starting from 0, that is fine. If they are not starting from 0, you have to do, if the values are not starting from 0, you have to do this sign here. okay, if they are not starting from 0, right? You can see that the values start from 0. So in this table, we start from 0. So there's no need to do this one, okay? If they are not starting from 0, you have to bring that some sort of, okay, like some wave-like sign here like this, okay, before, okay, but once it's starting from 0, okay, good. So 9.5 will map to what, 4 here. Okay, so this is my point here. Okay, so you here. So the next one is 19.5 is 11.5. So if here is 12 here, so that's 11. So if this is so 11 will be somewhere there. So 11 will be somewhere here. Okay, 11 will be somewhere here. Okay, then the next one is what? The next one, 27.5 is 17. So 17 is just right after this one, 16 here. So it's like a 4 interval, so maybe just at the top here like that. Okay, so this one goes here like this. Like that. And then the next one is what? Is a 3-point word. It's 20. So that's 17 is there. And this one is 20. So 20 is at the very top here. Very top here like that. Okay. Here, and then when you finish, you don't use a rule to connect them. You draw it with freehand. And because it is starting from 0, so you can just draw straight from 0 here with freehand. You don't use ruler for this one. Oh my God, my hand is not straight enough. So you don't use ruler, you just go straight for it like this, like that, like that, like that. Good. So this is that. So this is my cumulative frequency curve. And another term for cumulative frequency curve is called ogive. Okay, let's see. Okay. Oh, this one. Okay, so what I've drawn here is the word cumulative frequency curve. Curve is also known as the word ogive. Like that. So this one, this is the ogive here. Okay. And then with this ogive, right, what you are going to do, so this is the ogive, okay, so like that. So from here, then they will ask me to find my median. So now I've constructed my cumulative frequency table.
Sir.
Yes.
Please, that CB over there is what?
Class boundary.
Oh, okay, okay. Okay.
So we have the word. So with this one, then they will ask me to find my word. Now I'm going to find my median. Now when it comes to cumulative frequency, you don't add anything, whether odd number or whether odd or even sigma f, you don't add anything. All that you do is that you find a word half. So I'm going to find my median. Okay, my median, right? Median. I'm going to find my median. So the median, to find the median, first of all, you need the median position. So median position is just half 1/2 times the word, times the sigma f, times the last value, okay, which is the sigma f, which is the last value here. Okay, the sigma f here. So here you don't add any value at all, whether odd or even, you don't add any value at all. Okay, good. And this one will give me what? So the total here is 20. So to be 20 divided by what? 2. Okay, and that will give me what? 10. Okay, so that's a 10. So look at what we're gonna do. So here is my word. Here is my, let me take my marker again. So here, let me pick red. Okay, let me pick red. Okay, great. So here, so this is my 4. Okay, this is my scale here. Here is 4. Okay, and here is what? 8. And here is what? 12. Okay, so my median position will be on the what? 10th. So 10. So 10 will be the middle of this. Then you use your ruler and you trace. Okay, dash, 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 dash to touch this one. Okay, then afterward you trace it. You trace it here like that. So the value here becomes the median value. Okay, let me take it one more time. I'm taking it again. So when it comes to finding the cumulative frequency curve, okay, finding the median with cumulative frequency curve, what happens is that you will do where you will find your cumulative frequency. And how do you find the cumulative frequency? You add the frequency, the next frequency to the previous one, and then you keep adding. So here when I added I had 11 plus 6, I had 17 plus 3, I had 20. So after getting this 20, what am I going to do? Then here you don't add anyone for the median in cumulative frequency curve. You don't add any one value to anything. You just your sigma f, which is the last value of the CF, is what you use. Okay, and then what do? You find a half of it. Okay, so 1/2 times the sigma f, which is 20/2, which is the 10th. And then then you come to your graph, and then you trace. So you use your ruler to draw hidden lines like that, like that, like that, like that. So it touches the graph, and then you trace it. That's to touch to touch the x-axis, the marker line. So there, the value you get here, okay, will give you. So let's say, looking at this tracing that I've done, maybe the value there will be maybe let's say let's give ourselves like maybe 18, okay. But when you are using graph sheet, everything will be very clear. Okay, so the value there is what is 18. So if it is a max that we had it in class, then the mark 18 mark, okay, 18 is the median. Please, who doesn't understand this one? Who doesn't understand this one? In your exam, either one histogram or one cumulative frequency curve will come as compulsory questions. So please make sure you master this one very, very well. That's why I've taken my time, okay, to explain this one to you. So do you know what? I'm going to give you one simple table, and then when you do it, then we close. We are done for today. And then God willing, next time when we meet, then we'll do the word. We'll do the mean, okay? All right, great. So let me give you a very simple table that you are going to do it, and then from there, okay, good. So let's see. Let me give you something like this. Okay, let me give you a very simple table that you are going to do it, and let's see what you're going to get. Okay, all right. So let me give you something like this. Let me give you a question like this. You are going to construct your full table. Okay, so let's see if I give you a column 5. Okay, so let me give you the column 6. Okay, all right, and then let me make the distance 4, 1, okay, 1, 2, okay, like that. Okay, 4, okay, 5 in total, 5 as well. Okay, good. So something like this. Okay, so here, class interval. So the class interval is what? Is let's say 4 to 9. Okay, 4 to 9. Okay, 10 to 14. Okay, 15. Okay, 15. So let's see if we can do that. Let's see. Here we go 4.5. Let's see. Hence is 4. So here should be 5. Okay, so 5 here. Okay, 14 to that. So 15 to 19. 19 to, okay, 19 to, split.
20 to 24.
23.
I want to divide them.
23.
Yes, I'm coming. I want to do this one. Okay, so 19 to 19. Divided by 1. So so here will be 20.
20 over 53.
20 to 24.
20 to 24. Okay, 24. And then the
25
last
to
one.
29.
So the last one will be okay. Okay, last one will be 25 to
29.
Okay, so let's say the frequency, let me give the frequency to be 4, okay, 6, let's say 8, okay, 5, okay, the one here, let me put some 5 here, and then the last one, let's say 2. All right, so please draw the cumulative frequency table for this one. Okay, draw the cumulative frequency table for this one. Okay, good. So I'm waiting for it. Okay, so draw your full cumulative. So this one is the what? This one is my frequency. Okay, this is my frequency. All right. So you need a what? So class boundary. If you want to, okay, not necessarily you have to put class boundary there, but if you complete it, that's fine. And then you get the mark less than, and then your cumulative frequency is here. Okay, like that. Okay, great. Okay, so let's do it quickly, and then so that we can call it a day. Okay, great. We are doing this. So you draw complete. So question 1. Okay, complete your frequency. Complete your frequency. This cumulative frequency table. Okay, and then B, draw your cumulative frequency curve, and then C, use your curve to determine the median mark. All right, start work. Okay, so please finish this one and then we can call it a day.
One, two, three.
Ẹ ta kọ́ sí bẹ́ẹ̀ sì ti máa lè bá tún mi pàdé. Ah, ọ́fíìsì mi bọ̀ àdábẹ̀ náà mi máa dáadáa. Mẹ́gbọ́ jẹ ni.
Oh, maame lazy. Bedsheet ba ha.
Yeah, so please, are we done? Are we done? Hello? My people, are you there? Are you done?
Almost done.
Yes, we are done.
Okay,
Yes,
please
sir.
hurry up and let's do it. Composing question, histogram and cumulative frequency curve. One will go down in the exam. Okay, okay. One is coming in the exam. Okay. By the way, we have to fix another time because okay, good. I'll meet you. I'm supposed to submit the questions as soon as possible, but when are we supposed to have statistics class? On Sunday, right? Hello? On Sunday?
Yes, sir.
Yes, yes,
Okay,
please.
good. After Sunday, that I was.
Yes, please.
And for the other ones, I'm done with the question. But for statistics, I want to have the data collection. I want to, after Sunday, then I will send the questions. Okay. I'll have a rough idea of what I'm going to set questions.
I am.
Okay, yes. So after Sunday, then I will submit your questions. Okay, so all right, great. Okay, you'll be fine. You'll be fine. The questions will not be difficult. I set standard questions, so they are not difficult. They are standard questions. Okay, so let's actually do this one together. Let's complete the table. So the class boundary. So here will be what 4.5 to 9.5. Okay, here is what the next one is 9.5 to what? Hello,
Sir,
9.5.
the first one is 4.5, not 4.4.
It's phone I'm typing. Sometimes my hand is too far. And this one is what 14.5. Okay, 14.5 to 14.5 to
It's doing
so yes,
15.5
yes,
It's doing 15.5 instead of 14.5.
here 15.5 here. Yes, for 14.5, sorry. 14.5 here. This one is also 14.5 to 19.5. And then here is 19.5 to 19.5 to
24.5.
24.5. And then the last one is
24.5
to
29.5.
Okay, great. Then let's go to the mark lesson. Mark lesson is 9.5, 14.5,
19.5,
19.5,
24.5,
24.5, and then 29. Okay, so let's get our cumulative frequency. 4.
Sir,
Yes, please.
please, the much less than, please just repeat it again. I just want to know because I'm getting confused over there.
What is confusion here? There's nothing confused about this. The upper class boundary, just write the upper class boundary.
Oh, okay.
That's all.
Okay, okay. Thank you very much.
So here it's not so strict, but sometimes if you ask people to write it just like that, they may miss it. That's why you draw your class boundary and then you write your upper class boundary as your marker.
All right, sir. Thank you very much.
So 4 here is what 10.
10.
And here is what 19.
24, 27.
So 24. And then here is what 27. Okay. That is all. So from here, it's 20 what? 6, right?
26. It's 20. Is it 26? Okay, 26.
26. This
26.
class that 26. Okay, so from here you are going to draw the community. You are going to draw our graph. Okay, so let me duplicate this slide. Duplicate this one. So please.
Hey, you might help us also as well now. What's up?
Who is that? Is it a Nigerian movie?
Oh.
Oh God. Okay, so let me draw it quickly because I can see folks are tired. They want to sing unto the Lord. So let me hurry up. Okay, so here we draw it this way. And then so people are singing unto the Lord. Okay, that's beautiful. Okay, so here, so this would be my cumulative frequency. Those of you with the graph book, please use the graph book for us so that so the frequency in here will be mark less
than.
Okay, so here I'll write 9.5. 9.5 here. Okay, the next one is what 14.5.
14.5.
The next one is
19.5.
19.5. The next one is 24.5. The next one is
29.5.
29.5. Okay, all right. Okay, so let's see. So here you can see that this one is not starting from 0. So I have to do this some way here like this. If it's not starting from 0. Okay, so you do this here. Okay, if it's not starting, you just do some zigzag line like that, meaning that it's not starting from 0. So 9.5 was that is 4, right? So here is, so let me make my scale, the scale, let me make it 4, 4, 4. Okay, 8, 12, 12 here, 16,
Okay.
and then 20. So 9.5 is what? 9.5 is 4. So 9. Yes, please.
Please, it should be more
Please, I
than
use my
20
scale as
because we have.
centimeters for you.
It should be more than 20.
Oh, it goes more than that.
The CS should be more than 20.
So
Yes,
it goes to 20
right.
what? What's the last number?
Can use
20 what?
24.8.
Go to, so let's go to 5.
26.
26, the last
5,
number.
10,
24, 20. The
5,
last
10, 15, 20, 25, and then maybe you can put here 30. Okay. So 9.5 is what? Is 4. So the 4 should be down here. Okay, so it should be somewhere here. 1.5 is 4. Okay. And then the word 14.5 is what? 10. So 10 is exactly on this one. It's 10. Okay, it's 10 is exactly on this one. Okay. The next one is what? 19.5. 19.5. Okay, that is for what? That is 19. So 19, this is what? This is 15, right? So 20. So 19.5 will be somewhere just below this. Okay. So that was somewhere here. Okay, that's somewhere here like this. Okay. Somewhere here like this one here. Then the 30.4 is what? 34.5. Oh, this is not 24.5. Is what? It's 24. So 24 will just come just below this 25 mark. Just below 25 mark here like that. Just below the 25 mark. And that one is 26, just on top of it, slightly on top of it here like that. So like that's here. Okay, so then you just draw this zigzag stuff and you raise it this way up. Look on me. And then you use freehand. You don't use ruler. Freehand with pencil and join them beautifully. All right, so that is that for the cumulative frequency curve. Then the next question is asking us to find a word. We have been asked to find the
median position.
The median position. So we have been asked to find the median. Okay, so first of all, we need to get a median position. Okay, and for this one, as I said earlier on, you don't add anything to it. So what you do is that you find your what? Sigma F. Okay, you find your sigma F.
Number divided by 2.
Yes, please. Here, let's say, let's bring my so I'm going to find my sigma F. So it is what? So median position is what is the 1/2 times the word times the sigma F. Okay, sigma F. Okay, so that will give us what? That will give us
13.
So that sigma F is what? So that will give us what's the total? The total is what? The total is 26. So here is 26. So 26. 2, 6 divided by 2, and that will give me 30. So then you go 10. So this is my 5, this is my 10, 10 is here. So I'm going to subtract let me take my ruler here. So I'll pick my ruler 18, then I'll trace it this way. So those of you who use graph sheet, please might in somewhere there like this, like that. Okay, like that, like that. So you can write median on top of it with pencil. Median, like this. Okay, here like this. And then you draw this, 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 that. Okay.
Yeah.
Please, are you clear with that? So the value, yes, please.
I beg you. Look, the cumulative, the frequency is 20. The cumulative frequency is 26. Okay.
The last value of the last value of the cumulative frequency. That's 26. So it's here.
Okay, but the frequency is up to it.
The sigma f will be the last value of the cumulative frequency. We added it, so it should be, yeah.
Very good. It's 26. The 26 is an even number. Do we leave it like that or make it +1? Because since we are looking for the position.
That is what I said.
Leave it like that.
For cumulative frequency, you don't add anyone to it to find the position.
Okay, thank you, sir. Thank you, sir.
Doc, my question.
All right, you're welcome.
With the median you wrote on top, is it that we are using the ruler to rule the line, or we also put the dot there?
You use the ruler. You use the ruler to draw this hidden line to touch here, and then you project it down. So the median value is the answer you find.
Okay, we don't put the dot.
The value. You use the same thing, but how would you trace it, please?
Okay.
The tracing must show.
Thank you.
Whisper the answer to you in the exam room, and I'll mark you wrong for that. You will lose the mark. You have to write. Use pencil to write on top of it median. Then you trace that value here, and then so when you trace it here, the answer you get, then you come and write from the graph. Okay, from the graph, the median mark equals, then you write. So those of you who use graph sheet, what is the answer you had here? Those of you who use graph sheet.
16.1.
16.5.
So I had 16.1.
Okay, so we had 16.5. Somebody had 16.1. Somebody had 16.5. 16.5. What else again? Those of you with graph sheet.
16.1.
16.1.
16.1. 16.1.
Please, if my lady has said 15.1, that's correct. So that is the final. Okay. The lady said 16.2. So once the lady has confirmed the 16.1, I won't take any more answers. All right. So 16.2. So you will trace it from your graph and you get it here. So the median, see, this one is the median. You have this one is the median, but that's not the median. So from this, it is this one that it's the median position you will trace, okay, which will give you the 16.1. Okay. All right. Thank you very, very much. All right.
Hello, Doc.
Hello.
Hello, Doc. Hello, Doc.
Yes, please.
Please, will the scale change the median?
It shouldn't change it. You shouldn't change it. It's not supposed to change the value. It's not. It's not supposed to change it.
Okay.
So you have to be consistent. Okay? Yeah, it's not supposed to change it. Yes. Any questions so far?
Emmanuel,
Yes, please.
Yes, sir. Yes, sir. Sir, please, I have a question.
Please go ahead. Go ahead.
All right, thank you, sir. I just want to find out if with the curve, the cumulative curve, it should always start from the point of the x and y axis.
Yes.
That's the zero.
So if it doesn't start from 0, if they see that this value that I gave, it doesn't start from 0. So if it doesn't start from 0, you do zigzag there and you draw it up. So you draw it from top down, see like that. But if it doesn't start from 0, at this point you do some zigzag here to show that that zigzag shows that the values there doesn't start from 0. But if you start from 0, like the previous one that we did, this one, and this one started from 0, so that one you go straight from 0 all the way up.
Oh, okay. All right.
Okay. All right. It's the last question, and then we can call it.
So where you have the zigzag, where you have so the line, the freehand line will still start from that corner.
Yeah, but you have to do the zigzag before you draw it. You draw it, you make the zigzag and you draw it through it. It shows that the curve is in the number, the data we're given is not starting from 0. That's what it indicates.
Okay, sir.
Yeah.
I'm pleading with you, the slide.
I'm going to send it right now. Please, we
Thank
need
you,
to
sir.
end the class now. I think I've gone far beyond what I expected to get. I'm hungry. I have to go and eat, okay, before I collapse, okay? My tummy is burning, so please, I think we'll end here. Thank you so much, and then I wish you guys all the best. Okay. Enjoy your day. Hello. Yes, please. Yes.
This one is to the Sato and Genesis. The Genesis lecture, no. In fact, that day I was hot. The
Please
network
go,
they
please
allowed
go and
me.
watch
So
the video.
it is not there.
Oh, please contact your colleague. I'm very busy. Oh. I squeeze time to make this time for you.
I contacted the council of elders. She also says she's not having it. The genetics, only the genetics alone. Where we have
I've
the
sent
X and
all
Y.
the genetics.
The X and Y chromosome. So that is the slide that I'm talking of. The theory of genetics, the Mandela.
But we've not done it. I've not done it with you.
We have not done it too.
Okay.
Okay.
Thank you very much.
Okay, good.
Thank you
I
very much.
told you that what I got from doctor's platform is what I'm posting. I didn't post something out of that. I always forward it from whatever he posts. I'll forward it.
So he said he has given it to you, and that's what I'm also saying that I have not gotten it.
But I've sent the genetic, all the genetic stuff. I've sent all
Yes,
of
for
them.
that one, I've
God
received
bless
it.
you.
I just that what I'm talking of.
We've not done that part. Please don't worry.
Okay. You then thank you very much.
All right. So please, I'm sending the slide to the class right now. Nimatu, and then please, I'm sending it right now so that. Okay, so,
Madam Nimatu,
okay,
I
so
beg you, the genetics, if some of us have not gotten it, I beg you.
we've not done. I've sent the slide, but we've not done it. We've not done the genetic. We've not done
so
it.
I want her to quiz the slide so that we can also have first-hand information. I'm begging her.
Is it the slides that Pastor is posting on the platform? I've been forwarding them. Maybe you are not following. It's not once it enters the platform that day. Now I always forward, and Kafi also sends it the same way. But we'll still send it again to the biology platform. Forward everything to the biology platform after the lecture, please.
If you go back to the platform, you will see it over there.
We'll
Okay, so
re-forward it.
Nimatu, please, I have forwarded the slides to you. So please, just what we did today, I've sent it. I've also sent you trial questions. I sent you trial questions yesterday. Okay, on genetics. Okay, good. So
It has
please,
been shared already, please.
so make sure you go through that one as well. Okay, thank you very much for having me. Have a good day, and God bless you.
Thank you, Doc. God bless you. Those of you who are still here, check the biology platform. It's there. I forwarded it.
Hello, madam.
Yes.
Madam, I beg you, I'm
Yes.
in Takra. I'm not privileged to be part of the biology group. So my name is Edward.
Okay, so you hire me, I'll forward them to you.
Okay, and I'm just writing my number at the chat this thing right now for you.
Oh, okay.
Uh-huh. Thank you.
Thank you
I'm
too.
writing it Edward.
Uh-huh.
Madam, please, I've sent it on our chat.
Yes, please.
And the Edward.
Okay.
Edward,
I've seen it.
0243
I've seen
Thank you.
it.
God
Let me
bless
just do that. Oh, God bless you too.
you. Okay.
Let me just forward it to you. Bye.